And I'll go ahead and share my screen here. And let's go ahead and I'll go ahead and load up the big larger drawing that we had yesterday. And let me see here if I isolate. All right, there comes Mark. Good morning, Mark. How are you? Okay, he's still connecting to audio. Good morning, Mark. How are you doing? Can you hear me?
Hi guys, good morning. Can you hear me?
Yes, I can hear you. You hear us okay?
Yeah, Julio's here. Samantha running a bit late.
Oh, okay.
He'll
Well,
be
she
here.
told me yesterday she wasn't going to be able to make it,
Right.
but
Okay.
that you two would be here. So great. So he's
Yeah.
there with you. All right. So what we've done, what I'm doing now, and I just now got the drawing loaded, so you haven't missed a thing. Um, other than the drama of me killing the session and having to restart it and come back into it. But the question was, okay, we know how to limit what you want to uh, create your surfaces with inclusion and exclusion polylines when you're building a surface.
Right.
And by the way, Brian, that doesn't limit what you're selecting. That just limits where the surface gets built.
Okay.
So when you select stuff, it's still going to select everything, even on the outside of that, but it will just disregard it. But really what it does is it builds the surface out of everything and then it chops it off where that boundary is and throws that part away. All right, so here's a sample. Let's see, and I've got these little guys are block references. So I want to see if I can make some points out of these. Let me see.
When did you can pencil? Yeah. Well, you get it open here, but. Yeah. Yeah.
All right, we'll do points from entities, and we're going to give them a description of host. And let's see. It's called poll. Okay, let's do that. We'll say use the block name as description. He's up here. Here, these points at blah, 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 go okay. Sorry, one more time. I'm going to do something else with that. Elevate by surface model, that'll be fine. And we're going to only process inserts, which are the blocks. Equals to only points to existing. Okay, so say okay. And we're going to put that in File there, and we're going to elevate to the surface. All right, so we got 43 points, and there they are. They're all called pole. And even though they're labeled post, but the block name was pole. So let's see, we get some others here. We've got say inlets. Those are not blocks. All right, so let's find another. I don't call it sign. We'll do the same thing. We'll see points from entities. Use a block name as description. And there you see we've got some without any name. What's this? It says, oh, I see. So it says sign. I've got something to say pole. So if I look at my points, now I've got 3 points that are just point, and then I've got all these points that says pole and all these that say sign. Okay. And so they've been placed in our file. What do we have here? We have another block called manhole. Let's run that one last time and go. And okay, so now we got a bunch of different points, some with different codes on them, right? So, PT, POLE, SIGN, and MH. All right, so that would be something. So let's say we're going to exclude off the signs, or maybe the signs and the poles. Okay, so whatever we're going to do. So what we do when we build the surface then is you would go to triangulate and contour. You're going to run your command. Now this is what, you know, we're going to need to bounce out of this and set something else up here in just a second, but I'll show you where you do this from here. So let's write this and let's give this one a different name here. But what you want to do is you're going to look at, and we're going to not use that inclusion exclusion because we're going to let it do the shrink wrapping for us. Remember that little automatic part that's included?
Yep.
And let's see, I also wanted to, sorry. Well, looks like maybe Samantha's going to join us after all. Okay, so there we go. Now I got the contours off. But you can see all my Carlson points are in the drawing. All right, so now, good morning, Samantha, if you can hear us.
No, it's not someone. It's me. It's holding.
And then,
See, it's not something. It's me. Oh, okay.
all right. All right, so we go back to our triangulate and contour, and we've set up our file. We're not going to use these inclusion stuff. It's going to actually create that boundary for us with the shrink wrapping that's built in. But if you look on the selection tab on the very back tab of this item, so you can, now I told you before when you put the inclusion, exclusion that it did not filter. that your selection was everything. But if you check that first checkbox, then it will also act as a selection filter. So you can use it that way as well. You don't need to, but then you can say, specify these selection options, and you can use all of these different things. And I'm going to go ahead and use everything that's here. If I had any elevation text, I don't have any elevation text, but you can choose this as well from a file, a CRD file, or a point group. Okay, so we're going to use a Carlson coordinate file format when we do this. All right, so I'm going to cancel this and come back to it, but that's where we turn it on. So let's go up to the points menu and we're going to create a group. So we're going to say points, point group manager. And let's create a group, and we'll call this group points to triangulate. All right. And we're going to, first of all, include all. We'll put that on the include tab, include all. And then we're going to go on the exclude tab, and we're going to exclude. We set that from the list. We're going to exclude, say, the manholes. So I'll get one of those, and hold the control key down. I'll get a point and a sign, so that the only points that we're going to use are going to be those hole points, but we're going to exclude the sign in the manhole. Okay, so that's going to be now our group. And when we look at our group, we'll save the group. Here's our points to triangulate. And if you look at the descriptions, you notice I excluded what? PT, sign, and manhole, leaving me only with this one group. So you're going to have all these others beside. You're going to be missing the ones that you exclude when you build the group. Okay. So now that you've built that group, then when you triangulate and contour, you're going to go to your selection tab, and you're going to turn on to specify selection options, and you're going to turn on from file, coordinate or ASCII file, or a point group, and Carlson coordinate file will be the format. And then you're going to say okay. And it wants us to do that. We select our data first, apparently. I thought it would have asked me for the file first, but apparently not. So now here's the coordinate file. It's asking me to read, so I'm going to open that up. And now it wants me to choose by a range of points. I can limit it to point numbers. Choose all. I can limit it to a description, so I can do all that stuff right here. Or I could say group. So I'll say these points to triangulate. So that's now, if you notice my range of points, that's where it got placed in there based on the group name. But I could have, I wouldn't have had to do the group. I could have just said all points. And then if I knew, descriptions that I needed to include, but it's easier to exclude and put them in a group. And then we say, okay, it goes and builds that surface. And if we look at, let me turn off, or let me isolate here. All right, so that's got pole sign and manholes. So I'm going to put this in my 3D viewer. And with them there, just to show you that it actually did incorporate those points as well, I'm going to add the surface that we just built. And then I'm going to turn off the fill. And now if I zoom in here and I see my points, notice that they are now forming corners of the, corners of triangles to let you know that they did in fact get incorporated into that surface. I'm trying to find some that are left out of it, but it looks like they were probably already included in the possibly in the break line data. Let me see here.
Yeah, I think that answers my question. So when when I'm doing a surface for a new project, I'll have a list of points, descriptions that I don't want to include in my surface, overhead wires, utility poles, light poles, stuff like that. I'll create a point group in the beginning before I run my surface, and then I can go to specify, and then I can add a point group that I want to exclude from my surface.
No, actually you add the point group that you're going to include. In fact, I didn't exactly do this correctly. As I was just thinking through it. Because what we did, our point group now has let's see, what is it? It's just the poles. So the signs and the manholes should not be included. So what I should have done was when I ran triangulate and contour, let me see if I can get that figured out. So when I do selection, if I turn off, I need to also turn off this CAD points and Carlson points. Otherwise, even though when I gave it a group, when it prompted me for it, it also included the others because they said CAD points and Carlson points were going to be used. So if I uncheck my CAD points and my Carlson points and my inserts, I'll do that as well, just to make sure I get those block inserts from the Carlson points out of the picture. But I also want to include these from this file or this group. All right, so now when I do this, and I'll grab everything, and I'll use that same coordinate file, and I'll use this same group. I'll say, okay, now it should. And let's isolate. Uh, all right, so now I've got pole, sign. All right, I've got pole, sign, and manholes. They're all showing. So let me throw those in my viewer and then add my surface. And now there we go. That's what I was wanting to show you because here you see these are the points, those manhole points down here. And you can see they did not participate in this surface build, nor did these, which were those points when we have whichever ones we kept the pole but got rid of the sign or whatever. And there you can see the ones that did get incorporated. And there should be a few up here that are not. See, these are not, but some like in here are. Okay. Follow how that works then? So,
Yes.
so you have to, and that's a great question because I never actually tried that. I was just thinking through, I'm pretty sure that you could have done it, but that's actually how you would do that. And that's actually not a bad way. I've always done it by going to those individual points and setting them up as non-surface points
Yeah.
to edit the points themselves, but this is, I think, is a much easier way. And so the trick is that when you go to the selection tab, you first of all, you have to say specify your selection options, but you have to uncheck CAD points and Carlson points while after you've made your group, that it would
Mhm.
include the group of points that you want to include. Let's say points point group manager. Let's edit this. So we're going to include all, but then we're going to exclude. Let's just exclude the manhole, for instance, and instead of all three of those. And so that gives us, the others, it gives us more than one group. We get poles, we get signs, and we get those PTs wherever they were. But it got rid of the manholes. So anyway, we saved that group. And then when you go to build the surface, it asks you to select everything. And then it's going to prompt you to select the coordinate file that you're using. And then, and the reason it asks you, even though you've got it associated and opened with the file, it doesn't know which one you might want to use necessarily, because usually what happens when people build a surface using a coordinate file, they do that to keep from having to draw the points into the drawing. So you could even do it that way if you haven't drawn your points in. Now you almost always will have the points you're going to be using drawn in the drawing because you want to see where they lie in relation to other things. But you could make a bunch of points, say from a DEM out of the USGS quad sheet, and you got thousands and thousands and thousands of points. Well, you could use that as your point file. You don't have to dump those points in the drawing, but it goes out and reads their data, puts it in the surface, and leaves that data external. So that's why they ask you for another file, even though you've got one open.
Mhm.
Well, you select a file, and then you can select a point group as part of that, or just put in the description if you said, all right, I only want to include, so if you can wild card limit the description to include the ones you want, then you could do it that way as well. But if it's more of, I'm only going to exclude a couple out of a list of many, it's easier to build a group and go from the group name. So,
Okay.
okay. Or
Yeah.
and again, you saw that you can limit it to point number ranges as well.
Yeah.
But the key is to unselect the Carlson points from the filter box up above where you're going to choose the CRD file. Otherwise, it will include those when you select them. All right.
Okay.
Okay, cool. We learned something. I learned something. Thanks. Great question.
Yeah.
So, all right, let's do this. I'm gonna, let's see, we'll come back and I'm gonna turn my videos off. You guys can do that as well, or I can do it for you here. I can't turn your videos back on, by the way, so don't worry about Big Brother here. Just going to do that to save a little bandwidth, and we'll jump back into talking about our survey side of the world now. Now we left yesterday from doing some Kogo work. And since you guys do this kind of work, are you is everybody familiar with, or does anybody want to see some tools that allow you to create points? How do you create points on certain things? Um,
I'm familiar with creating points.
okay. How about you guys, Mark and Julio?
Yeah, I created points on grid works, like for an airstrip. I did
Uh,
like 10 feet, 10 by 10 intervals.
oh, okay. So
Yeah,
you,
grids, and then the program generate, you know, points
yeah.
for all those intersections.
Okay. And you know how to use points from entities. So if you've got a bunch of, let's say you need to stake out a subdivision with all the property corners, you can just filter,
Yeah,
filter the layer to show the lot corners and then do points from entities and get all the endpoints of the lot lines, things like that, right? Everybody's good with those?
Yes.
Okay. All right. So that's basically, I think we'll step aside from that. And so we get into the rest of some of these tools where, this stuff is getting so complex and rich that, we really need a good solid week to teach some of these classes, but it becomes, people can't afford the time away from work, much less the fees to, pay somebody to work for a week on teaching this stuff. But, anyway, so we'll go over what we can and get done what we can. So let's look at some of these survey tools. So we'll skip past our coordinate geometry. Let's go to, because I want to spend the bulk of our time mostly on, or not really the bulk of, but a good bit of time on our field to finish. So let's go next and talk about some raw file processing. So I think, Brian, you said that you do some like traverse adjustments and things like that for your work, I
Yes.
believe.
We
Okay.
don't work out of CRDs. I mean, we export CRDs for our field crews, but we don't just import a CRD and trust it. So we take the raw file from
Exactly.
that day's work, and then we go through it. We print out what the original was before processing, and
Yeah.
then we'll go through, we'll edit it, and then we'll print out the post processing, and then bring it into our drawing.
Excellent. Excellent material. So I had a survey class I was teaching down in Mississippi one year. And I was showing him this, and we're talking about, why do you first of all, why do you adjust your survey measurements? Why would we do it? And there's a little discussion there on page 59 in your manual that talks about it, because otherwise, really what happens is if you just accept the raw positioning of each of those, let's say you've got a certain amount of systematic error in your instruments, and maybe it scales everything a little bit, just a slight percentage, but it scales everything a little bit long across the whole thing. So what you're doing is you're pushing everything long, 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 long. And then when you come back to close back in, where you're going to tie back into either some other known coordinates or back to your starting place, which is actually, well, if you tie back to your starting place, it won't catch scale errors. But anyway, your misclosure, all of the error gets put in the last measurement. And so you want to be able to make these mathematical adjustments that we're going to distribute the error evenly across all of the measurements, so you can, hopefully correct that systematic error. Now, the problem is when it comes about is if you have, a bust in your measurements where all of the error is in one particular setup and observation. Well, then that's a different kettle of fish there. That adjustment will still, iron that part out, but not it's not as robust as what we use adjustments for, which is to distribute any systematic errors that are not already sort of negated by the some are positive, some are negative. On the average, you're going to be, canceling each other out type of adjustment. So we got that. But anyway, I was teaching this class down in Mississippi, and I was talking about that, and the owner of the company said, let's not even talk. We're gonna let's just skip this part. Says we don't do this stuff. In fact, if any of my crews came back in and they had misclosures, you know, more than if they weren't just exactly on. So I'll send it back out to do the work over again, because our instruments are high quality now. They're going to be reading blah 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 blah. So so that's some some of the attitudes. And so he did every bit of his work without any kind of adjustment. Now, the other thing to consider as well is if you're doing a job and everything is done with GPS observation, and if you're using if you're tied into a real-time correction network or something in the field, those adjustments are going to be done for you there before you ever leave the field. And they'll come back in, and those are CRD files you could just bring straight in. Although you can actually process and adjust a GPS. And if I said GIS earlier, I meant GPS, I'm sorry. But you can adjust those files as well. So it corrects the vectors, but it's not the same type of adjustment. You're talking about putting adjustments on, vector lines that are 11,000 miles long, from the satellite back down to where the observations are made. So it's a different animal, really. But least squares can help fix some of that out. But let's sort of keep it down on the simple level and talk about these raw files. And first of all, to know, what is a raw file? And raw files are basically a record of commands or observations that create points. So anytime you run a bunch of coordinate geometry computations, it's always a good idea to turn on a raw file right before you do it and then capture all of those commands, because that will keep like an audit trail that you can go back in and change it. Again, it's like adding up a bunch of numbers using a spreadsheet versus using a calculator. So you can go back and make edits to things you may have had a mistake on individual entries. Okay, so, but we also capture a raw file with our data collectors. When we come back in from the field, we've got the raw file, which has the actual observations in it. And that's an excellent source to hang on to, because let's say you get some bad elevations. Well, maybe somebody forgot to record a change in your rod height, or the instrument height. Something might have changed that they didn't get down correctly, that you can potentially recover, especially if using fixed height rods and things like that. But in any case, you get the idea. So we're going to start a new file. We'll just make an empty file, your choice, put it wherever you'd like to work with it. And then we're going to open up this raw file, or actually we're going to create one as we go. So we'll make a new one just, or we can even, in fact, I'll tell you what, let's save a little. Let's save a little time. We'll just open this one up called raw file 1. So, all right, so we'll go back to Carlson. I'm going to do a new drawing and just take my defaults. And as it comes up, I'm going to give it a set. I'll go back to my survey class. And we'll just call this one raw file. Proc, that's my drawing file name. That will also become my data, my coordinate file name. There'll be no projection system here. I'm not going to be in any kind of state plane. This comes up, there's now my coordinate file. I'm not going to do any imports or anything because it's going to be empty. I'll just hit next, and now it's going to come up and come here. Now, does anybody ever get this particular warning when you start things up and you wonder what it means?
I do not.
All right. So if you do, here's where that comes from. It was pretty obscure to track that down. When I'm working, I'm gonna go with my settings, my Carlson configure. So when I'm working on things, I like to use, and it's down here at the bottom of the left-hand side, this annotative scale. That way my scaling of my text entities and even your points can be set to be annotative, so they can react to some different scales, as you set them up. And you can create new ones as you go on the fly. And there is a little switch here as well that says set annotative to drawing scale. Okay, and that switch right there is, let me cancel that and show you here, is when we are setting up the drawing and you're setting your drawing scale here. With that switch on, it's going to create the annotation scaling for the drawing. Now, if you don't know what I'm talking about when I'm talking about annotation scaling, that's okay. And you can, continue to work without that. But it has to do with down here in this bottom scale, you see this annotation scales list. And it's when you use annotative text or an annotative block, anything like that, as you change scales, it's going to rescale the text or the block to keep it at a consistent size, even though your scales change. So right now I would be in 30 scale. And so I would normally see this thing, make a scale called 1 inch equals 30 feet and set it accordingly. And so now when I do a piece of text, it's going to be, I'll give it what's called a paper text height of, say, a 1/10 of an inch or a 1/4 inch or an 1/8 of an inch or something. And then if I change that scale, it will resize that text entity so that it maintains that paper text height. But this trigger down here at the bottom where it says 1 inch equals 30, if you noticed, mine said 1 inch equals 1 foot, or 1 foot equals 1 foot. And I've got 1 foot equals 30 inches. I see right now something that I've got screwed up here. Carlson can figure. It shouldn't be foot equals inches. It should be inch equals feet. All right.
After you set that scale in model space, when you switch over to your sheet setup, is
Yeah.
it gonna match the same scale that you were in your model space?
No, you still have to set the scales of your viewports.
Yeah.
Now well, like right now it does.
So I'll already know, I'll do my sheet setup and I'll know what scale I have my project at. So when I go into model space, I can annotate it to the same scaling. And when I bring in my line work and my text, it'll match what scale is in my paper space.
Yeah, so that is correct. So, but what that switch does is, if I say that I want to set the annotative to the drawing scale, what happens with that is that anytime that I change this right here, it's going to go down and automatically change my annotation scale, and it will even create a new scale. Let's say I changed my drawing scale to 1 inch equals 75 feet, for instance, something stupid. Then it would go down here to my list of annotation scaling, and it would create that new scale availability for me and set it to match that. That's what that little switch is supposed to do. But what I was asking you about is if you'd ever run into this, where it says, due to a known limitation, it's unable to set the annotation scale for a drawing saved in an older DWG format, right? So what happens is, or what happened was, in this case, I'm still using a really old drawing template that was saved from, like, 2004 version or something. And so that's why it's not able to do that. And it's telling me that little warning message. Now, I don't know that the AutoCAD version gives you that warning. The IntelliCAD version will. And that's why when I changed scales up the top under my settings, it did not automatically update my annotation scale like I would normally be used to seeing. And so I would have to go down, and I can manually change it down at the bottom as well, and everything's fine. But to have it automatically linked to that, it needs to be a newer drawing format. And when I start this drawing with a template file that was saved in the old formats, then it's, you know, it inherits that limitation from that old format, and it won't, you know, it just disables that automatic switching. So the way to fix that is just open up your drawing templates and then do a do a save as, and even save them back as another template, but you have to save it back as a, first you save it as a new version of DWG, and then you save it again as a template file. It's complicated, complex and all that, but if you ever get that and wondered what it was, that's what's going on, and it has to do with your drawing templates, okay? So anyway, moving along. So if you've got your drawing started, we're going to go to the survey menu now, and we're going to edit and process a raw file. And this is going to come up. We've got new and existing. Let's go ahead, just to save a little time. We'll go to existing, and let's choose this raw file 1. And we'll see that it's going to pop up, and it's going to be very simplex.
Is this a raw file that you have in the data set folder?
That is correct. And as you can see, it's really quite simple. And everybody has that. Anybody, excuse me, anybody need any more time or need any?
It just asking me to create a CRD first. So I'm just going to create a
Oh.
brand new CRD, and then I'll bring in that raw.
That's fine. All right, so there's just a couple of things that I want to point out with with this, if you maybe are or are not aware of when you're collecting the stuff in the field. But as you are creating observations, let's see, if I sit on, say, this first shot where I'm sitting on point 1, I'm looking at point 2 is where I'm creating, but my backside record, I'm looking at 1, and then I backside, let's see, well, first of all, I stored point 1, which is, you know, right in here with this, it's under 0.5 at the same location. It's very slightly, you know, it misses it just a slight amount. Anyway, that's no big deal to prove that. You get the idea. It misses 0.5, but that's where it starts at 0.1. It backsights this 0.99, which doesn't really exist yet at this point. I'm just backsighting that. And so I'm setting up my backsight record here with an azimuth of 270. So I'm occupying 0.1. I'm observing an azimuth of 270 or due west. And I'm putting 0 on my, I'm zeroing out my circles here. I'm zeroing my plates on my gun. And then I set up, I'm going to traverse occupying 0.1. I'm looking back to my due west. I create 0.2 by turning an angle right of 180 degrees and go 100 feet, a zenith angle of 90, so it's dead level. And I give it a description of, excuse me, Trav 2, whereas 0.1 has CTRL1, blah, blah, blah. And then I just traverse my way around. So that moves me up now to my next one. I'm on 0.2 looking back at 1, because I traversed, it knows my previous occupied point is now my backside point. I'm on point 2, I'm setting point 3, same thing 3 to 4, and then 4 to 5, and then 5 to 99. So if I'm sitting on 4, looking ahead to 5, I'm closing back in on that starting point, again, which is not, it's not ideal field craft. We really should not close back on ourselves. We should close back on 2 other known coordinates, because when you close back on yourself, you're going to miss finding any distance scaling errors, because it's just going to be a closed figure. It starts at the same point, and because the scaling is proportional, you can draw your shape all the way back around and close back on yourself, and it's going to always be, to that point. You won't find a difference in distance. You won't find a misclosure distance to be able to help you figure out how much distance scaling to adjust. But anyway, that gets into another class in survey observation adjustments. We'll save that for another day. But we look at this observation. Now, one thing to notice is when I sit on any given line in my little spreadsheet editor, you can see it's highlighting down below in my map. Now, if you're not seeing the map and stuff like that, I'll go over here in just a second where make sure we see all those things correctly. But that shot, instead of being a traverse shot, is a CL shot. That's my closing distance shot. And then my angle balance shot is the turn where I go back to close the horizon back to my original backsight observation back, and that sets my 0.99. That's what creates that one. But you can see that, and looking at my numbers, I had a 180, then a 270, then a 269, 59, 58, and then 270 to 90. So everything is nice and square except for that one particular observation. So same thing, it's not quite 100 feet, it's 99.98 to set these up. But do you guys use these check-in shots? Because when I'm traversing through and I'm setting 0.5, and this is my way of saying that 0.5 should also really be 0.1, is you put the equal mark in the description. Are you guys doing that?
Yes, so we will start on point 2, backside point 1 with an azimuth, turn in point 3, run a
Yeah.
closed loop trav, and then when we get back to 1, say we'll overlay it, it'll be called 8, and then in the description we'll put Magnail set space dash 8, or space dash 1, meaning point 1 is also point 8, and then we'll do the next setup. 2, it will be our closing. And then we'll do a traverse for each point, and then we do close, angle, and balance all on one line.
Yeah, okay, what you can do. But what I was getting at is that the equal character in that description. So if you go to your on the process menu and your process settings, right here in the middle where it says checkpoint settings, when you report those as checkpoints, it's looking for that, for whatever character that you use, and maybe you're using the dash to do that with. So whatever that is it's going to flag it that, oh, hey, that's a checkpoint. I need to compare that to that original coordinate. And when it gives you the closure reports, it's going to also report those. So even as you're working your way around, let's say you get around here to 0.3 and you can run in through 0.4, but it's something you've already established and you got some known coordinates on it. You can say 4 equals, 1367, whatever it happens to be from something else. And it will look that up and compare those 2 sets, but it's based on that equal mark as
Yeah,
description.
I did not know that. When we do our compass, it'll have the overlaying turned angles. So like 1 and 2 will be 7 and 8, but I didn't know you could go in there and put an equal sign
Yeah.
to an overlapping traverse point.
Yeah, well, I mean, it can be any character that you want to use, but
Yeah,
equal makes sense. So
yeah.
yeah, that was the part I wanted to sort of point out to you here. So, all right, so next one, does everybody, when they get this up, are you able to see the mapping? You see the graphics as well as the spreadsheet? Is anybody
I do
not?
not.
I'm sorry?
I do not.
Okay. So to be able to do that, and again, there's a bunch of commands here in these little menus inside this box. There's also a bunch of buttons down here that are the same commands. I'm not sure if there's every one of them or not, but on the display menu is fourth down is graphics, which is on or off, and then you can show side shots or not. Then zoom mode, pan mode, or pick mode puts your cursor in a particular one, and then your text sizes and such like that. But that can turn that on and off. Now, the button for it is if you hover the mouse over these buttons down here below, you see the one that shows the pencil and the little mark that says graphics on, graphics off. So I'm just
Yes.
clicking that, okay? So that'll help you to do that. Now, there's also a setting to where when you find, when you're sitting on a particular line in the spreadsheet, it's going to highlight down in the picture which observation that happens to be. So now if you have your cursor set to be, right now mine's in zoom mode, but I'm going to set it to be this, right in here are the cursor modes. There's this graphics pick mode, the one with the plus on it. So if I choose that, now I'm going to go down here into the graphics and I'm going to just click on a leg up here and you see it links me back to the spreadsheet as to which record that is. See how it's doing that? So it's nice when you get a really big network that you're trying to work around. Okay. So just a couple of things there to help orient things. There's also a couple of other things you can do. If you hide your description records, now what description records are? That right there where it's got headings, that's a description record. Every line in this list is a record, but that's a record that's just a description of what's coming next. There, it had to change headings and it has a new description. There's a new description. Right, so those are your description headings. And if you choose under display to hide your description records, I'm sorry, I lied to you. The description records are actually like comments. That's these DSs. All right, well, it's not the description records I was looking for. It's the headings. Show my, yeah, there it is. Hide your record headers. That's it. Yeah. So now you're just relying on knowing what these little codes over here mean. And so if I show the record headers, yeah, that's what those are, record headers. Sorry. But the other description records are going to be, you'll see when we open up another more complicated file, you can see those and see how you can get yourself around it. You can also set those colors. You know, there's a lot of stuff is set in that, you know, in your settings with your just, in some process settings, there are some, let's see, where was the, that it was, I guess you'd do it individually then under like display. So yeah, the spreadsheet colors and spreadsheet settings. So here's these different colors for different record types you can set there as well. So spreadsheet settings, use large fonts or not is about it as far as the heading goes. So is there any particular one that was good? So hide and show your side shot records is another nice one. We don't have any side shots here, but it'll really help us to get some clutter out of the way when you're doing this. So in any case, this is going to be something. Let's go ahead and let's open up our other file for the moment, just to give you a little more complexity so you can see what's going on with that. So I'm going to go up to the file menu and I'm going to say open/new raw file. And when it says save changes, I'm going to say no, I'm not going to make any saves to that. We'll come back to it later. And let's get this raw file 2 now as our next one. And you can see there's a lot of records in here, and some of which these DS records, those are our description records. And that's where you can hide your description records. So all of those get suppressed, or you can show them. So turn those on and off, and you've got buttons up here that'll do that as well. You've also got down below, here's a graphic zoom extents. So you can see everything in this little bit larger traverse, but notice the side shots are not there unless I turn on either through the display menu or through this little SS button to show the side shots. And as you can see there, the side shots are, you know, quite many from the work. So that will help you to clean up some things or go back and use them or to see them where they are. In fact, you can come back to pick. If I wanted to see, you know, what set that particular point, right there was a side shot. I was sitting on 5,500. I look back at my previous setup to see, there's my HI record. So my HIs are all, that doesn't make any sense. Let's see. If these are all being set from sitting on 0.5 thousand. Oh, I'm sorry. Yeah, I was thinking, you know, why is my instrument height changing? It's not, it's the rod height. So that's where I'm putting in different rod heights here and here and here. So that makes sense. But I can look back and see. Yeah, and here we say the height changed at 0.3167. The old height was 901. So just a little description note. Again, 5,000. So 5,000 set quite a bunch of points. And now there it is. So that's 5,000. I'm backsighting 5,001. And now I'm setting these side shot records. So I could have, if I had traversed through, if you pick up your side shots as you are traversing, you actually don't need to enter a backsight record. But if you just make a new setup, so 5,000, 5,001 were already created. So that's why we have a backsight record. In fact, let's go up here to the top and we see we've got points 5,000, 5,001. They're stored. They're traverse PK nails. Bonus points since you guys are so young. Anybody know what PK stands for?
It's not a nail.
It is a nail, but you know what the letters P and K come from?
Do not.
Okay, this will be a little trivia. You can use it at your next survey company party.
Yeah.
Christmas is coming up. It's actually the brand name of the company that manufactured the nails that was called Parker Kalon, Kalon. And so they just became, you know, the one company all over the country that everybody bought those nails from. and they're a concrete penetrating nail. But it was the Parker Kalin company, and that's how it got its name. Now every surveyor in the world knows what a PK is.
I'll
But
definitely be using that.
yeah, we had when I started my college days, I spent my first 2 years out at the Air Force Academy in Colorado, and we had we had as freshmen out there, you know, you're crapped on daily by the upper class people, and they'll ask you questions about general military knowledge and whatever else, and you're expected to know and to answer, you know, with these questions. And if you don't know, then you're expected to try to find it out by, you know, asking somebody else around or looking it up or something long before Wikipedia. But they would stop you and say, you know, who was Emil J. Pater? Well, nobody ever heard of Emil J. Pater. And, you know, you'd get in trouble for not knowing. They'd send you on your way, and, you know, they tell you, you better know the next time I ask you, and blah, blah, blah. And say, how am I supposed to find this out? Well, you know, you see this man's name at least once every week or once every 2 weeks, whatever it was. And, you know, it was just impossible. Nobody knew what it was. But anyway, it was the name was the manufacturer's name of the barber chair in the barber shop. We had to get our hair cut once a week. And when you sit in the barber chair and you put your feet in that little, you know, the footrest that holds your feet up off the floor, and in those old barber chairs, the name of that chair company, or the, you know, the old barber's name, whatever, said Emil J. Pater, was right down there between your feet. And we looked at it every week and never knew it. So any chance you get to pick up a little trivia, well, knock yourself out. So that's what a PK is. It's Parker Kalon. All right, so there's a couple of things that you can do with that. And again, with your you know, if you turn the side shots off and just and that's the let me go back to my zoom extends. So there's my actual traverse, side shots on and off. You get the idea. So it can help clear up some clutter. And so this went from, you know, 5,000, which is over here, 5,001's over here. And we had a little closed loop traverse on itself here. And then even though it's established as a fly traverse to set 3190, not really, you know, it's actually recorded as a side shot, it looks like, but it's side shot dash trav. So it's identified separately as a fly traverse because there's no other observation out there from it. So anything else to note? All right, so let's go back now to the previous one. Let's go to File, Open / New raw file, and choose that raw file 1. What I must have hit the wrong. Oh, I'm sorry, I did the coordinate file. So there we go. So raw file 1, I'm going to come back to this little simple one that we have so we can understand what some of these controls are. Unless, I mean, do all you guys know, I don't want to waste a whole lot of time on this necessarily, but there's a couple of techniques that you can use to help you find a couple of things, if you will. For instance, this has a specific angular error right here in this line 3 setting 4. There's also a distance error there. So there's a couple of tricks. Now, let's say if I were to, let's say I had that I'm going to put my distance up. I'm just editing that record directly. I'm making that 100, but I still have this angular error. Okay, so now my my work is correct all the way through, except for this one angular value. So it should have cranked on around to 270. It didn't get all the way around, so it should pull the close that 0.5, further down below where it's supposed to tie back into one to be a perfect square. You see how that would happen? In fact, let's make this, let's just make it 250. And now you can see it's really, opened it up so that it's not closing where it is at all. Okay. So if there's a couple of things to know about finding blunders that are contained at a single setup. If you were to look at the misclosure of this particular traverse, say between 5 and 1, imagine there a little line drawn between 5 and 1. If you have a bust in an angle at one of your setups, it's generally the case that the bisector, or the if you consider that line of misclosure, go to the midpoint and construct a line that's perpendicular through that little misclosing line, then that line should point to the setup that contains the angular error. And as you can see, and you would just pick that little line and perpendicular up, and you just move it all around and point to whichever one. And that perpendicular line should basically bisect the angle at the point where the error is. And you can see that if you got your misclosure out here between 1 to 5, you draw your perpendicular line through it, and it's going to hit over here into 3. And, it will bisect the angle there at 3. So if I put this one back to say 270, and let's make the angle down here at 4, let's call it 310. All right, so now look at 5 to 1. And if you put a perpendicular bisector between that, on that misclosing line, and then if you see if I can get this. To work out, so my angle is here. My exterior angle. Maybe it has to be. That's split. No. Trying to figure out the rule. And when these are so large, it's hard to find them. So let me see here, 270, 250, so that's perpendicular there from, so it bisects the angle, but it would have to be the angle between what it is and what the line should be. Yeah. All right, so that's fine. But anyway, we don't have any tools that's going to find that, but we do have a distance tool, blunder that's part of the, or blunder detection that's part of this. So if I put this back to 270, 270, and let's make a distance error pretty obvious. Let's say 2 to 3. We'll make, say, 120 feet instead of 100 feet. Okay, so now you can see your misclosure. And so the misclosure on any given figure, now it's sort of obvious when it's a square, but when whatever that line of misclosure is, if it's in a distance bust, the misclosure line is going to be perpendicular to whichever leg of the traverse contains that error. So you could just pick that line up and move it all around your traverse figure and check out all the lines that are at least close to being perpendicular to that misclosing line. And so it's not, in this case, I have two potential lines that I would have to check, 2 to 3 and 4 to 5, to check for that as a particular bust. Now, anyway, the reason I did that is, let me put this back to what we had before, 269, 59, 58, and 99.9. So anyway, the reason I was telling you that is there is a tool called, when you do this processing, that you can try to find a particular error. Let's just how it apply. Yeah, find bad angle. So if we have a bad angle, let's go back to number 3 here, and let's make that one, instead of 270, let's make it see, we'll make it again pretty obvious. We missed it. And I don't know that it's going to find this because there's not enough closure information. But if I find the bad angle, reference closing point should be 1. Starting point 1 to 5, automatic, that's good. And so the measured close point 5 to 99. Yeah, see, I don't think this is gonna work for me, but closing angle. Yeah, so it says 110. Yeah, see, that's not. Bad angle is set up 1 foresight 2. Yeah, so I don't have enough. I'm not constrained enough because I'm starting at 1 with just a backside azimuth, and I'm closing back and then reestablishing it. If I do this the correct way, if I traverse this the correct way, I'm going to start with 2 knowns, and then I'm going to close on 2 other knowns. And once I've got the geometry constrained that way, it can find a particular single bad angle. I don't know, I haven't seen a whole lot of data sets where surveyors have done that, particularly in the days before we had GPS, where your local control might be, half a county away on some mountaintop, and nobody was interested in, doing any kind of continental triangulation to set up a local site survey. So all understood, but anyway, there are a couple of tools that are part and parcel of that. So, all right, so let's look at some of our processing next. If you go to the process menu and pull down that all the way to the bottom, look at your process settings. There's just a couple of things that you would set up here as part of your work. You've got your distance tolerances and vertical, horizontal and vertical distance tolerance. So if it's less than, if you've got mismatches, and these are from multiple measurements at the same setup. So if they miss by more than these particular amounts, it's going to flag a warning for you and report these residuals. Now, these numbers should be, something that you get from your equipment. You'd have your, the repeatability numbers from your equipment that you would put in to match those equipment. And so they want to know your average types. If you're doing averages, you're averaging multiple measurements. You can average, it will average all the distance measurements first and then compute the coordinates, or you could tell it to compute all the coordinates and then average each individual coordinates. I don't know why they really give you that, because mathematically that should still give you the very same results. As to whether you average all the distances, compute once, or you compute several times and then take the average to resolve that into a single computed average coordinate. But in any case, there it is. And then if you have a backsite coordinate file, which it's a little bit misnamed, it really is just a control file. So if you if you've recorded an azimuth in your backsite, but you're using control points from another coordinate file. In fact, that's another thing you can do, is establish a secondary coordinate file to use as control points, and it doesn't include them in any adjustments. It only works on your locally attached file. So that would be that one. You can store the backsite point if you don't have one, if you're just let's see, if you're using that external coordinate file, for instance, then when you observe that backsite as part of your records up here, it will, if you're using it either an external file or if you're just recording an azimuth by sighting on a church steeple or something across town, then it will, yes or no, based on what you want to do, you can store that as a backsite point in this particular local file. Okay, now here are your checkpoints. We talked about that earlier with that little whatever character or characters. You can put CHK or whatever you wanted to use that tells it to check against the other point, for the other point numbers. And these again are the tolerance values, horizontal and vertical, for the checking. Okay, so when you check into a point, it's supposed to be, if it's outside of that tolerance, it's going to issue a warning in the reports. Okay. And then your store point records, if you want to always store the points or only when you don't have a point there, or you don't want to store it until you're, through all your adjustments and everything, then you can do that on exit from this raw file processing. So I would just leave it to always, because even when you do your adjustments, it's going to overwrite them and then, record them. All right. And then you can also tell it to, if you compare, you can report anything that are stored. I'm sorry, your store point records. It's not whether it stores the records, it's when you have a store point record. Like up here in our little file, we've stored point number 1 as 5,000, 5,000. So if I say never do that, or I don't want to store that into my coordinate file, I'm just using it as a means of computing the rest of these, but I'm not saving it. So that's what that means. But I like to always kind of put these in here. And then you can compare measurements to any store points, report those store points. You can hold those store points, or you can unhold them and let them be part of any adjustments, and convert occupied to point records. I don't really know the advantage of that necessarily, but anyway, you get the idea. And then here's your data checks, where you can report any blank descriptions. Here's your instrument height values. So if there's anything outside these ranges, it will flag a potential problem for you to go back and check. Balance and your direct and reverse vertical angles as to whether you want to balance those. Foresight backside, same thing there. Horizontal angle, tolerance, 5 seconds, and a flip tolerance, again, 5 seconds on when you flip the scope and spin it around. So basically, you know, the more expensive the Autolite, the smaller that number is going to be generally. So any measurements to control points, you can store them to this coordinate file. Yes or no. And then you draw in your points and your line works. You can actually do that again right inside of this by field to finish automatically. I generally save that for outside this work myself when I'm working on that. Okay, but you have that option. All right, so those are some of the settings. And now here's generally the process of how you would do this is you should almost, at least I like to run a no adjust, and all that does is computes it and gives you the results as a report. So I'm not going to do any adjustments at this point. Multiple measurements, calculate elevations. Well, I don't have any. I'm not observing any elevation data. It's all zenith angles of 90. Point protect, et cetera, scale factors and things like that if you're doing some geodetic level work. So I'm going to report my closure. You can also report any side shots. We don't have any in our records here, but you could do that. Turn it on and off. And now my reference closing point is going to be point number 1. So I put a 1 and hit tab and it reads the information from point number 1 and I'll say okay. Now my traverse points, it knows based on the records that I started at 1 and I went to point 5, and that was my automatic, or you could set it to prompt, and when it does that, it gives you this, and you can take things in and out of your traverse record. But generally, if it's recognizable and when you put this in, it's going to know. Going to recognize what it is. So I'm going to leave that as automatic. So 1 through 5, I'll say okay. Now, the initial results, what are we computing here? We have a raw file, coordinate file, a scale factor of 1, no earth curvature correction. Here's my closure results. I start at point 1, 5,000, 5,000. I have a closing reference point to 1, but my ending point was 5. Therefore, my error, my azimuth of my error line is 92, so nearly due east, and it is, you know, 0.001 in the north, 0.02 in the east, and I've seen some surveyors that are thrilled to get something that good and they'll live with it and go on their merry way. I'm not big with that 200s. I think I can do better than that, but that's still, you see what it's got. And that gives me a precision of 1 part in 21,000, basically. In the old days when I was first getting started, and it wasn't that many days ago, this was back in the 1980s, there were some, you know, rural communities and you know, localities that was an acceptable closure. You know, 1 part in 20,000. Oh, what the heck? It's good enough. Let's go with it. And off you go. But you can see, get the idea. So now, again, it's going to report now my my raw measurements unadjusted. So there's my 180 and 100 all the way down. There's 269, 59, 58. And there's my 99, 98. So there's all my measurements. And it recorded that last closing angle, close angle to my 0.99. And there's my store point because I stored 0.1 and my checkpoint, because remember I used that equal mark. So my reference 0.1, my measured 0.5, and there's my deltas. So that's how much it misses in the north, how much it misses in the east. and how much it misses in elevation, which ours are not going to have any vertical error here. Right. So my horizontal distance of 0.02 is going to give me that, and line 9 occupied 4 site distance, horizontal angle. Not sure what that is going to be telling us. Is that particular last line of anything that you recognize, Brian, since you use these a lot? It's giving me a line number for line number 9, but I don't think that, I think my data is too simple in this case for that to indicate. I don't think that's a guess as to a bad
No,
spot.
no, that's not a line item I recognize. The last one I usually have, the last set is the adjusted.
Yeah,
But
if
when
you
I'm
run,
running it through Compass,
yeah,
but I
if you
don't
run
think,
an adjustment, it would be. So maybe it was just because that was the last, that was my closing shot. I don't think. So line 9, so that is the checkpoint. That might be all it is, and I don't know, you're running an earlier version than me, aren't you? Aren't you 2020?
yeah, 22. I mean, our office has 25, but we have like a whole
Yeah,
variety of all the
yeah,
PMs,
but
so anywhere from 18 to 25. So
yeah, but what I'm asking about is that, do you see that in your report for this no adjust report? Do you also get that LN?
yes, I do.
Think in even earlier versions, I don't know that they reported that line, and I think all that is telling you the line number of your data that that sets up the checkpoint. Okay,
I
because
don't think I typically see it because I don't use that equal sign for a check. So I'm seeing it now because of the equal sign 5 to 1, but I
right.
usually don't see that line.
So if I had, let's see if that was a good let's see if that was a good theory. So if I do this as no adjust, now it's going to be, I'm going to have a huge miss on that, but yeah, so see that showed my 0.4. It's basically just telling me what line number in my data is this little flag. That's all that's what that is. So and we'll put that back. Okay, so now, so that was with our no adjustment. Now there's a couple of things that we can do adjustment wise. You can, and this is usually done, or this was more prevalently done back when our angles were considered to be more accurate than our distances. And that was in the days of our transits. We could measure our angles fairly precisely, but our distances were measured with, steel tapes, and we're holding tapes between, our thumb and our forefinger and a plumb bob hanging over the point. So most of our adjustment was done into the distances, but in case there's a particular, like an angle that's causing an issue. In fact, let's see if I change that one. I'm now back to having just an angle here as an error and keeping my distance. I don't think that's going to illustrate what I'm trying to trying to say. There we go. Now. Yeah, so I exceeded my tolerance on my miss down there on that check-in, which is fine. It's what I meant to do. 1 part in 39. So anyway, what the next step would normally be was if you do an angle balance, then what that's going to do is to balance the angular error and distribute that between all of the angles in the figure without consideration of the distance adjustments. And then it recomputes that. And then when you do your other computation, and we'll leave these set to this gross amount here so you can see the effects of this. So if my reference point down here is 1 again, and so 1 to 5, my traverse, and so the measured closing points are 5 to 99. The measured bearing is south 89, 59, 58, which gives me a measured azimuth of 269, 59, 58. But it should be, let's see if I can pull it up. I don't think that will do it. Now let's see if I go the reference closing angle. Let's see, 5 to 99 should be azimuth 90 degrees, 2 seconds. Closing angle is 270. Yeah, so I've got 2 seconds of angular error. And then that, when I get my report, it gives me, there's my original 1 in 39 bad stuff. So here's my original data. And then I get to, there's my checkpoints. So now at this point down here starts my angle balance. So it takes this angular error of 2 seconds and it adjusts each one of those angles by 4/10 of a second. And then it computes the closure results after it balances the angle. So it does that recomputation starting here, going to here. And now it gives me the closure still didn't improve it. There's 1 in 39. Let me put this back up, 99.98. All right, so let's see. All right, so there's my original 1 part in 20,990. And then once I get down to my angle balance where I've applied the per angle adjustment of 0.4, it just balances the angular miss through all the different angles evenly. Then that puts my precision at 1 in 20,588, which is a little bit less than what I did. But again, I haven't adjusted anything yet. Okay. All I did was, I mean, I adjusted the angles. Okay, I spread the angles apart. So that was the angle balance. And then when I do these next adjustment techniques, now, Brian, are you guys using least squares or
When we do our adjustment,
yeah,
we're doing compass.
you're doing compass rule. So these are all risk. Now, here's the deal on these adjustments. The compass rule adjustment is now there's 3 of them. There's compass rule, there's Crandall adjustment, and the transit rule adjustment. The transit rule adjustments, I think, are where it more favorably considers the angles. Or considers the angles to be more precise than your distances, and Crandall is the other way around, distances versus angles, I think, if I recall correctly. And then the compass rule is it means where they're evenly weighted in the distribution. And really, when you look at the math of it all, it's nothing more than what they call a special case of the least squares adjustment. It's a least squares adjustment where every observation is given an equal weighting of 1. And so all of the terms cancel each other out, and it simplifies down to what is the compass rule adjustment. And so what that's going to do is to apply these angled, differences to each observation, the distance as well, through its algorithm to come up with these numbers, is what we typically use and what makes the most sense when we have modern theodolites where we have a combined total station where we're measuring the angles quite precisely and the distances quite precisely. And so, any of the systematic errors like setups and centering over points and all that, because, back when we're using transits and tapes, we had to take the transit off the tripod and move it off the point to be able to tape between stations. It's not exactly the case because we could hang the plumb bob under the tripod and measure that way. But anyway, all of that kind of stuff is considered for that adjustment. So if I choose this now as my compass rule adjustment, my reference closing point again is point number 1. Now I've got this choice right here that says apply angle balance, yes or no. Okay, so if I've seen some people do this and they'll run that report that I just ran before where I just applied the angle balance to see how that helped me or not, and it didn't. So then we'll uncheck that so we don't apply it. So it's not really, I don't really have a good rule of thumb for you as to when or whether or not you should apply it. It's unless you're aware. Now, it's the air data is so goofy because it's got this artificial error in it. But if we're pretty comfortable with all of the angular setups, we knew that, everything could be seen. It wasn't too long a shot. So I didn't really have any no pointing errors at any one given observation more so than the others, then I would consider applying that angle balance to it as well. So let's just run it once with it on and then once with it off, and you can see what the effects are going to be. So that's going to be 1 to 99, which should be as with the 270. And again, there's my 2 seconds of angle. I'll say okay. There's now my first precision, my raw precision. I get to my angle balance section here, and I get that closure precision there of 20,500. So it goes down a little bit. Then it's going to check these and come up now with my adjusted elevations. And here's my compass closure. I've got these original points and then their adjusted coordinates. So, this is obviously I've introduced, I know the intent is supposed to be 5,000 and 5,100, 4,900, 51, 4,900, obviously. So, here's my adjustments. Here I've got a 5,000ths in that point number 2. I've got 100th, point number 3, 100th and a half in point number 4, and then almost 200ths in point number 5. So you can see how it's accumulating that and carrying it through. I've got a max adjustment of that much. And So what does that give me now? I'm looking for. So here's my angle. My closure after my angle balance. Okay. Let me print this over here for a second. Let's see. It's not gonna. If that was with angle balance and now without. Oh. All right, so there's my original. If I don't do my angle balance, I just go straight to the compass closure. Yeah, see it's not, the adjustments on these are exactly the same as they were, whether or not I did the angle balance at all. I guess all it's doing really, and I think our data is so artificially set up that you're not seeing the results of it. So basically what it's intended is that you take all of the angular error and you balance that through evenly first before you do the actual computed adjustment. But what's normally the case with modern equipment is that we don't do those angle balances. We're going to account for, the angular miss by just incorporating that as part of each observational adjustment. Does that make sense? Do you understand what I'm saying there? I'm having a hard time articulating this, but um, it was a typical step in the process back when we measured our angles separately from our distances. Like we would go through, and in fact, some traverses we'd go through and measure all the angles without measuring any distances. Get all the angles recorded, and then we go through and measure all the distances separately. So that was the intent behind that, was to balance then all those angles out first. And, the assumption being that all those angles were measured as precisely as they could be and evenly precisely, or the same level of precision at each one. And so whatever errors, whatever random errors and systematic errors were in that traverse were justifiably spread evenly among all of the angles of the traverse. Okay. And then we would apply the adjustment to the remaining misclosures on each of those points. So the angles do get adjusted more than just that amount. It would get that amount first to balance them out, and then it would make a lesser amount that gets adjusted by the compass algorithm. Man, that doesn't even sound clear to me. I apologize for that. Um, let's open. I'm going to go back to file and open that other file, raw file 2. And let's do this one a minute and see if we can find it. See, this is 5,000. 1, 2 to 3 to 4 to 5. And then 6. Don't know. Let's see here. This is 7,001. The same as 5,001. Okay. So my reference closing point should be 5,001, I think. $5,001 to $7,001. That should work. All right, so that gives me, well, look at that. That's one part in 138, 139,000. So that would be something that a lot of people would never bother adjusting. Let's say I reported all my side shots. I'll turn that off next time. There's my store points, my checkpoint. 5,000, it's not too bad. All right, so next, if we look at our angle balance, and check the side shots, my reference closing point should be 5,001. The reference closing angle is 5,001 to 5,006. I don't know what it's supposed to be. I do that, it's not gonna. Yeah, see, it thinks I've got a 12-degree angular error, so that's not. Yeah, I don't know what that is supposed to be for my angular balance. All right, so 5,001. I won't apply the angle balance, and there we go. So that was that. 138. There's my checkpoints, pretty decent. Store points, adjusted elevations, real nice agreement there. There's my compass closure. So each of these points, original and adjusted, looks good. A maximum adjustment of 5,000ths. And these are my adjusted observations, as they should be, to compute those angles. All right, so then once that's done and it's made those adjustments, I wish I knew what 5,001 to 5,006. So it's 5,000, 4505, 78. If I save coordinate file and exit, then if I inverse 5,001 Uh, Crap, now I forgot what the point number was. $5,006, okay. One, 6. Jot that down real quick. That is Southwest 73 2604. All right, now I'm sorry, I want to do the angle balance. There we go. So now 5001 to 5006. What did you say? Southwest 73 2604. Measure for 5005. Measure closing bearing. Boy, something's 5001 to 5006. No, I'm not sure. Do you have any insights on that on your end, Brian?
I typically do it in a different way. So kind of see the shape of the traverse is built like a balloon. We only do loops, so I would start at 5002, backside 5001, turn in 5003, and then I would continue with my loop. Once I'm on 5005, backside in 5004, I would foresight 5006. I would occupy 5006, backside 5005, and then I would turn 5002 into 5007. And that would be my overlap, and then that's the loop I would balance. And then now 501, a 502 and 501, you would be mimicking as 507 and 506, and that would be my overlap. And that's what I would balance, angle, and adjust. And then if I wanted to set 5006, I would close my horizon to it and just set it almost as a spur.
I see. Okay. Yeah, because this is not, yeah, see, I would normally do that same way. I would, instead of having that closing angle out to that separate thing, if I were doing loops, if I were doing closed loops, which actually a closed traverse to me and even a loop can go from two unknowns to two other unknowns. But let's say I'm doing a like this, we make a circular close on itself figure. I would sit on a point, backside a point, take off, run my stuff, and I would close back around to the point that I started on and then close back to my original back site. That would be the way I did those.
Mhm.
So that would be
My-
my horizon.
Yeah, yeah, I would occupy my original back site, and I would be foresighting my original setup, and that would be two overlaying points, and that's how I balance them out.
Okay, that gives you some redundancy on that. But
Yeah,
so if you're looking at, so if you're starting your traverse at 5,002 to set 5,002, so you've got a backside 5,001 when you start at 5,002.
yes.
So
I
that,
kind of just like them to go sequentially, so it makes sense in my head. Like
yeah,
even though I'm starting on two, I'm backsighting one, I'm closing back out. I'm going in one direction.
right. So if this were the way I would normally have done that, I would have started 2, go around, get to 5,005, and then when I would then, I see what you're saying. You then close back to 5,002.
Yep, because that would be because I'm angle and balance closing over the same original points.
Yeah, you're coming back
then-
to your start point instead of that other, okay.
Throwing that 5,006 makes it wonky. I have trouble if I had to balance that in Compass, I would have trouble with that. It's a little wonky.
Okay. All right. Well, let's not spend all of our time sitting here trying to dig this out either. So let's leave that to further exploration. Um, I can't figure out why it's not doing that angle bounce. And I've not ever really done much delving into that little nuance of getting those angle bounces, but I've had times before where it would sort of show automatically. Uh, but I don't know if they've changed something since the version I've used. Anyway, let's push ahead beyond that so we can spend some more time. And speaking of pushing ahead, we're actually way past our 10:30 break time too. So let's take our break. And so it's now 10 after. So let's come back at 10:20 or 11:25 or 25 after the hour, wherever you are in the world.
Yep.
And we'll pick back up from that, and we'll put this, if you're not having any issues on that raw file, but the one thing though, that do you turn on your raw files and capture those for Kogo captures?
I'm not sure.
Like when you compute points, are you just doing those sort of on the fly? Or what I'm getting at is when you're running some Kogo comps,
Yep.
you, and I don't mean reducing field notes, I mean just setting computed points. You can turn your raw file on from your, see here, you come up here and you say raw file on or off, and you can capture a new raw file and it will capture all of those commands. And then you can go back and use that raw file editor. So let's say if I turn this on, I'll make a new one called, just call it Kogo. And so let's,
Yeah, that's typically how I do it. I do draw locate points. I typically don't go into Kogo. I'll create a layer for it and a point series, and I'll either screen pick or coordinate.
yeah, so I've got some points. So let's just see what we've got here. If I've got some points, and if I'm going to calculate some points, I've got 3204. I'm going to say I'm got my point file is on, so I'm going to inverse from 3205 up to 3204. All right, so that's now what my setup is. And I'm going to set a bunch of side shots. So I'm going to pick, all right, so let's just say angle code of 7. We'll go 180. We'll just go 180. 50 feet. Vertical angle. And we'll call that just SS. All right, so there's my 7,002. Now I'm still on that setup. And let's go 270. Oh, sorry, 270. Another 50 feet, side shots, another set. All right, so I've got you know, one dead ahead, 190 degrees off, and then let's do a say mm, and then we'll exit that. Or no, before we exit it, let's traverse. So now we're going to go to that angle cut is 7. So let's go 182. Same. Let's go say 225 at 100 feet, and that will be a traverse station. And now we'll exit that. Okay, so now these are all new points. Back here were my original two setups, 3204 and 5. I set 7,002, 3, and 4, and then I traversed up and set 7,005. But let's suppose that now say at 3204 and 3205, it goes, oh man, that wasn't right. I should have been, you know, looking at 3013 instead of 3205. Well, because, and I'll turn that, I'll go back to Kogo and turn that file off and say close file. So now, just as if I brought that in from the field, I edit process that raw file, I'll choose that Kogo file, and now you can see, turn the side shots on. So there's my 3204, backsliding 3205. So that's exactly like what I did. And you can see if I mistyped something, I could change it individually here. Or if I said, instead of backsliding 3205, I should have been backsliding, hang on a second, can't see enough, say 3267. So I could just 3267. So that's going to basically take everything here and just give it a rotation. And once that's done, I don't even have to do anything other than just save the coordinate file. And you know, there's no need to adjust it because it's just a computation. So now I've done that. Save the changes to the raw file, yes. And now these points are out of position, but if I redraw them, see if I double sorry, I double click it. No. Did I get that? Say 3267. Yeah. So I guess I do need to at least run it through no adjust. Okay. So reference closing points. Doesn't matter. I'll exit that. And then update raw from points, or save the coordinate files. That should. There it is. Now they're in different locations. So I could, you know, tell it I wanted to, you know, do these individually. It's going to put it back over there, or I could just redraw the points. And that was 7,002 through 7,005. So see what it did is it flipped everything based on that new orientation, but So all I had to do was if I had I wouldn't have to go back and try to recompute all those points again. As if and you can imagine if you've got a whole lot of these points to have to do, sorry, edit process raw file. It's keeping track of those as just part of your, they're just part of your computation that you've done. So you just set a bunch of side shots and traverse, did a setup that was accomplished by running the inverse command. So, and you could do, any number of other commands that you're doing, like your, your intersections, you got your bearing distance, and all those different intersections. You can compute resections. All of that kind of stuff can get captured in these raw files. And then you have those to go back and edit and reprocess if you need to. Okay. Line on and off, that simply does, it draws lines between any traverse records, but not side shot records. But I don't generally draw my maps by drawing my traverses. All right, so now we're back down. Another 10 minutes have gone by. We're going to come back at 25 till the hour now to get our 15 minutes. All right. Any questions on anything about the adjustments at this point, other than why? Everybody good?
No, I think I'm good.
All righty. So see everybody back at 25 till.
Okay.
Okay, good.
Okay, everybody, I'm back if you are.
I'm here.
Okay.
I'm here.
Okay, so let's jump into the money part and start developing this idea of our field to finish drawing and how we can get some benefit and some mileage out of that. So we'll be starting, say, at about page 67 in your book. We're going to make a new file and load up a new coordinate file and import some points. So to just stay in my blank file that I had there, I'll turn that off. Let me see. Make a new drawing here. Let me see if I can get a more recent standard survey. Maybe that will be, maybe not. See if I get that warning at the bottom. Yeah, looks like I did not. So good. I'm going to go to my data sets. I'll call this one F to F example. And we'll get 30 feet again. 1/10 of an inch for my symbols, 8/100ths for my text, no projection. Let's say next. And we have a coordinate file that we're going to create called F2F example, field to finish example in my case here. And we can either import directly as part of the wizard, or I'm just going to leave it set to none and we'll do it as part of the next step. And
Yeah,
so,
move back.
okay, Mark. So what we're doing is we're pushing ahead next into our field to finish in the book starting on page 67. So we're just going to start a new drawing file, put it in our data set folder, and we're just setting it up, taking our defaults. I've got it set up here. It's empty. I do have a coordinate file of the same name, and there are no coordinates in it at this point, and that's where we all are. So if you'll get yourself a file set up, then we should be good to go. Let me know when you're ready to go.
Yeah, where do I get the sample?
There's no sample. We're gonna make a new one,
Oh, okay.
make a new empty
Okay.
file. And I would suggest saving it in the folder that has all of those sample files in it. And there's gonna be, there are some other files in there that you can use for reference as you're going back over some of these things like, say like this one here is sort of, I can get this to come back. So this is the completed exercise that we can make from field to finish with based on what we're going to do next. We're going to open up the coordinates and everything, and this is all almost completely done in field to finish. And we did then compute the surface and have it draw the contours and label, but everything else is good to go. It all came out of field to finish. Okay, so we're going to see how we actually went about doing that. So we've got line styles, we've got overhead power, we've got sanitary sewer, we've got some property lines here called AP. Let me turn the line weights on, maybe go back to model space. And what is our scale here? It's 50. So yeah. All right, so that's what we're after, is to get something like that to sort of come up and give us what we need, and to draw edges and things like that that we're going to use. You can tell by the way these contours say cross this edge of this pavement that was being drawn and used as a break line, as well as you can see these that come up. I think you can see them better here. Let's turn this back off a little bit. So these contours, you can see how they come up and they hit these edges, and but that's what's made these contours make these little jog arounds, is that they were set up as break lines, so that points over here can't look across this edge and see points over here and start making flat triangles. So that's what we're after, is to have this thing come up with our break lines for us in particular, but also to create our our symbology and put things in the right layers and things like that. Okay, so that's where we're headed with it. We'll do that from this empty drawing. And there's a couple of other techniques. And so there's a couple, well, actually there's a few things I want to share with you as well, to show you this, to what you have. If you look in your if you look in your data set folder, let me show you some extra stuff that you've got that I'd like to point to you. We're not going to take time in a class to go through it, but inside of here, there's this data sets and it's got, those are the files that we've got that go along with your documentation, right? But then there's also this F2F quick start guide. This is your field to finish quick start guide. And this has a number of other files in it as well. There is a drawing template. There is a coordinate file. Then there's two PDFs in here. One's called Easy Start and one's called Advanced Guide. There's a configuration file, and there are two different field code files, and then a tree setup file that helps control the codes as they respond to trees, okay? And I want to show you just a little bit of this as you go through it. And this is from my friend Doug Aberg, who's a surveyor that's been around for many years down in the southeast part of the US. And he's got this, you know, documented very, very well as things come about. And he's got a data set that will produce this this little site survey, and it's all in 3D. So it will come up, you know, it will create all the break lines and edges, and he shows you how to have it do things like, you know, rotating around catch basin symbols to match up against, you know, curb lines. So it gets really, really detailed, but it's something that, you know, you're going to have, you'll be able to pick a lot of this from um, some more advanced study, like using symbol blocks and 3-point symbols and things like that. Here's a real good explanation of all these special codes as to what they do and how you can use them, because they can be done in multiple ways. Here's, you know, how like a power pole, not sure what he's indicating with that. Like it's a circle command. He's using a PP, a power pole circle. So he's setting it to basically generate, although you can't occupy the center of a power pole and then go shoot the edge of a power pole. I don't know what he's trying to do with that. But anyway, you get the idea. He's got this just real nicely documented, but he tells you the steps to go through here and using all of these, where to put the files, how to configure, how to use the drawing template. And so, you know, you'll need to make sure that you're going to save off your settings and then load up his settings from this configure file and that kind of stuff. All right. And that's the easy start. And then the more advanced start. And this is something that if you guys are not using this part of this yet, as far as field to finish, it's really quite um, good in terms of these extra things like tree surveys and utility surveys, pipes, that sort of stuff. And he gives you the files. Here's some more things like these 3-point symbols, you know, for accident scene reconstructions, for instance. How to build templates and curbs and such like that. Patterns, multiple point coding. We're going to get into some of that as far as what we do today as well. So anyway, take this stuff and work through it. It's really, really rich and helpful, I think, to explain and document all the little nuances of these options. The one I'm trying to look for is talks about the tree setup. Advanced text, adding text from field notes, etc. You can put all those all as part of your field to finish. GIS attributes. Adding inverts to sewer structure, just like capturing and carrying your GIS data along with these points, but the what is, it's still GIS. I want to try to find the anyway, somewhere in one of these two books, he talks about how to set up these tree and utility options. So like you could actually, you know, head up a whole library of different trees. Oh, here it is. I think I stumbled right onto it. So here it is on, yeah, in this advanced guide on page 25, he started talking about how he's setting up a code that's going to be a tree type. And if you can, you'll see this over here, there's a feature type. It's either going to be topo, tree, or pipe. And topo is, to me, a bad terminology. It's either planimetric, tree, or pipe. But anyway, that's what the coders did. But anyway, so he's got a code CT set as a tree feature as opposed to being a topo feature. And there are two tree types, deciduous trees and coniferous trees. The annotation of the trees is controlled in the setup, and here's his setup, and he tells you, you choose the button that says tree setup, and you would put all this in here, and you tell it how to label these when it comes into the drawing, and how they're labeled and described can be as simple or as complicated as you want to make it. Okay, so once that's done, going to draw a block, draw a tree table, so it can actually generate a table of different trees with tree diameters and calipers and all of the different symbols for different trees. Change the size of the symbol, you know, based on the size of the tree that's coded into it. And it's, like I said, it's really trying to see if there's a picture of the finished drawing. I don't see with the table. Okay, so anyway, come off of that. We'll come back to ours. And let's see if he has, we're in our data sets. In that guide, he's not got a specific DWG. Okay, so that's what I was checking on. All right. Okay, so anyway, what I want you to do is when you get all your tremendous amounts of free time, go through those field to finish guides. They go into real deep dive into there, so it can really help you flesh out you know, what those are going to do. And I'll show you a couple of those things that we just won't have time to jump to in class, but we'll get to them as well. All right, so what we have now is an empty drawing, and we're going to load up our coordinate file. So we're assuming that, you know, Brian has processed it and given his adjustments, and the surveyor has given their blessing to it. And we got a good set of coordinates. We're ready to go to work. So let's go and get those points into our coordinate file, because right now it is empty. So let's go to the points menu, and we are going to import a text or ASCII file. And our little dialog is going to come up, and let's choose select files, to the button at the top. And let's be in our data set folder, and let's find this one that's called plat.txt. And let's open it up, and it gives us a little preview of the file so we can verify the coordinate order and the format that we're going to use. And it's going to be that P comma Y comma X comma Z comma D. And if you want to know what those letters mean, they mean this over here on the left-hand side. You can actually type those in any combination you want in here. And if you type S, that means it's going to skip. So if you did not want to get your elevation, for instance, you would type that as P comma Y comma X comma S comma D. Or if you didn't want descriptions, you could just say P comma Y comma X comma Z comma S, meaning skip that part of the data. All right, so we will do no adds to the point numbers or names. All files with an asterisk in their descriptions. We're not needing to skip any header lines in the file because we don't have a line that's non-data. We don't have like a header file. If we did, or multiples, we could tell it how many. We'll take all the points and our draw points. We're going to pull that down and choose draw locate points. So I'm just going to do draw locate points just to bring the points in. I'm not going to draw with field to finish just yet. We're going to do that a little bit later. And then a point group to assign is you can give it an assign. You can assign a point group that will automatically create it. It's going to put it in this group called imported. Okay, and now I think that's all that I need. I'll say okay. And it comes back and says 54 points have been read in. They're now going to bring this up. I'm going to set my dialogue here. I guess that's all I need. V node. I'll change that to just be V dash node, not control. Draw all should be available, but it says draw range. I'll just say all. And there now are my points. And I don't have any idea why, but my point defaults never stick. Ever since I've moved to 2024 version. So yeah, I don't know. So now I'll draw all, just redraw those. And just because I'm an anal retentive engineer, I'm going to change that ugly font to give me a little better looking point. There we go. So as you can see, you've got a bunch of random points that have nothing, but they got a bunch of point symbols, point numbers, elevations, and descriptions. Not exactly a finished plat that we're looking for at this time. If we look at our points, let's go to the points menu and choose edit points so we can get the whole set of points up in a spreadsheet and we sort of see what's going on. I've got a point here that's FL space CM. Now, Brian, do you guys or any of you guys that use field to finish, are you using double coding? Like in this?
Like when they're in the field, we use a dash and then like 18 or 4 DEC for deciduous, or so there are multiple codes you can put in for one shot.
No, more what I mean by double coding is, let's say you pick up the corner of a gravel driveway where it comes in and hits the edge of pavement, and you're like running down the road and you're catching the edge of pavement, but then you're going to get the edge of gravel.
Mm-hmm.
That same point, that same where the corner of the gravel hits the pavement, and then you
Yep.
could. So
We do like bit space GRV.
yes, okay. So
Begin. So you could have active line work and then add another active
Cool.
line work off of the same point.
Okay, so you're taking advantage of what's called double coding. I've seen
Yeah.
some people are actually, they'll shoot the point twice just to get it in there. So I just wanted to make sure that it's not going to be a new concept for you. So
Yep.
that's good. All right, so that's like this first point right here in this editor. It's FL space CM, so that's a fence line and it's a concrete monument. Okay, so that's what those are. Meaning that here's an iron pin and it's a fence line. All right, so here's now these are not double codes, but these are special codes. PV, that's pavement, and PC is the start of a curve. Start of a curve, start of a curve. Same thing down there. And I've got an EP, start of a curve, and then end of the curve. So pointed curve, pointed tangent. And that is essentially it. In this little file, that's what we have. So we're going to learn what all of those things mean and how they can control. You know, a lot of you and you folks, you know, that are using this, you're going to be familiar with a lot of this stuff. But you know, to understand where these are and some of the little differences that you can make happen, that can really be helpful. So the one thing that I would suggest that you try to communicate is that when you start to use field to finish, to make it the most effective, you're going to need to have the guys in the field be as consistent as they can be. So like you don't want, you know, one day they're going to decide to call your edge of pavement EP, and then the next day they get up and decide to call it EOP or anything like that. I've got, you know, that surveyor I was telling you about yesterday that always shoots the building walls up too high. He has a habit of, I guess because he did it for years, you know, when he gets something around a curve, something that's along a curve, what the way this works is when you start, let's say you're doing edge of pavement and then you hit a curve, well, you would say EP space PC, meaning you're going to start the curve. And then every EP point after that is understood to be on the curve. But he changes it from EP to be POC. He'll call it, you know, point on curve. And, you know, I don't need to know, the computer doesn't need to know that as far as a code. And I could never get him to grasp that it's the PC that turns the curve on, and then everything that follows is on the curve until it hits a PT, unless you're not using PT coding and you're just taking the 3 points that define the curve. I like to make sure I definitively use PT, but that's me. Because you can have more than one, you can have more than 3 points to define a curve. So anyway, that's just my rule of thumb. All right, so what we have a bunch of points, and they're just symbols and attributes at this stage. We would like to see this help us to flesh this out as part of a process. So we need to use field to finish to do this with. And what field to finish is going to do is it's going to read our coordinate file, and when it sees those codes, it's going to look up that code in our feature definitions, our field code file, our feature code list, and it's going to put that point. It's going to basically do a draw locate, choosing a particular symbol, placing it on a particular layer, and using a particular line style to connect points of the same description, if that's what we intend to do. Now, so part of that consistency that I started talking about in the field is when these guys are out walking the ground and collecting points, they need to be thinking about, you know, they are building the map as they go. In other words, if I've got, you know, the edge of my parking lot might look like this. And then as I'm, you know, and then maybe I've got another feature, you know, maybe it's maybe it's also the, you know, the edge of the Sorry here. Let's just call that like a parking lot. So, and then, I might have some manholes and inlets and trees and, the center of the road might be, no, excuse me, the center of my road, might be over here. I'm getting the roads and maybe edge of pavements or whatever. So the key is to make this work is they thinking they're creating this map as they go. So if they come in here and they grab this point, let me just move this up to be. A little bit more what I mean. So if they're coming along, say down this edge of pavement. And as they're working, all right, so let's say we're so we're sorry, that and all right, now. All right, so they're out there in the field and they're working and they're coming down the road and they're picking up edges of pavement, edge of pavement. They need to do this as they traverse the site, as they're going along the site. Now, you can do something like this. You can start up here at this upper end, say, call that an EP, and come down and get the next point. Maybe there's a bend or a change in elevation or whatever. You get another point EP, but then you're going to see this parking lot start. And maybe that's going to be, BIT for bitumen or GRV. Let's say it's a gravel parking lot, maybe a gravel driveway in a parking lot. So I'm doing up here EP, a couple of EPs, and I get to this point, and maybe I don't need to define that point as far as the EP goes, but because there's another point that's along it that's also going to serve this feature, I'm going to call that EP space GRV for gravel, for instance, or EG, edge of gravel, whatever I've got. So you need to learn as you go along. So there's nothing that says you can't interrupt what you're drawing to go pick up other things. Maybe you go EP, EP, EP. Oh, here's a manhole. Get a manhole. Come on, and there's a fire hydrant. Now there's the edge of gravel, and you get all of these points as you go. So you're turning on with you say EP because that's an edge and you need to create that and capture that as a break line. So you want the computer to draw that for you automatically. So you're going to have a code that you use that's going to create that drawn edge. And usually that's something like EP. If you've got center lines in the middle of the road and you pick those up, CL, 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 instead of just leaving a bunch of random points, make them connected with a line between them. So, but you need to do these in order. So when you have a point and you connecting them, the field to finish system is going to draw to the next point number it sees with that code. So you don't want to shoot this point and come way down here and shoot the end point and then come back in here in the middle and shoot these points in between. You can do that. And you can do that one of two ways. You can, let's say if this is point number 101 and you came down here, this is point number 102, and now you don't have any room, if that was 105, you could make this 102, 103, but you can also make this 101A and 101B and then 102. So you can sneak points in, that you might have missed, but you want to keep them in point sequential order, usually. That's one way to do it. The other way to do it is in the field to finish control file, you're going to tell it to connect points based on proximity and not based on order. That gets tough. That's like drawing something through nearest found. And sometimes it's not the right way of doing it. Sometimes the nearest found is not really the way they're connected. But anyway, the whole idea is to make this work, you need consistency and you need the guys in the field thinking about how they're creating this map as they go along. And like I said, there's nothing wrong as you're doing EPs and EPs to step aside and pick up some of these other things along the sides. But you want to get all of the EP points all along in one particular direction so that the lines draw in the correctly. You don't want to start here, jump down here and draw, and then backtrack on yourself and then backtrack again. Now you can, you know, run two of them or three of them or multiple ones of them at the same time, and you're going to do that with code suffixing. So you would have an EP and an EP1, EP2, EP3, that sort of thing. So once one of them's open, it can stay open until it's closed. But that's the idea behind it, is that when you're in the field, collect this data as if you were making a map right there in the field, okay? So all of that will hopefully become obvious once you're starting to do the work. All right, those of you that know it, I apologize. I know you're already familiar with that. So what we need to do next is to look at field to finish and figure out how we make it do the magic. So right now we have nothing. So let's go to the let's go to the survey menu, and we're to come down here, the first command in the third menu section called draw field to finish. And that's going to bring this up. And we have some controls here. A range of points or a point group or whatever we're going to draw, and then the entities that we want it to draw. And I'm going to say points, lines, symbols, and 3D faces. And you can limit, you know, you can filter the distance and all that. I'm going to leave all those unchecked. And you could put a prefix on the layer these things go on. There's no need for that. I will erase existing field to finish entities, and I will erase in range. So if I'm changing a different range of points, it's only going to erase that range and redraw them. And that's so that when you erase these, that's if you're doing it again for a second pass, it's going to erase the previous ones and then redraw this new pass. Now, this additional draw options button right here, go ahead and choose that, and that's going to give you some control on how these things work as to what you want to see, point numbers, descriptions, notes, attributes, whether you want to use elevations, label it as 0 elevations or not. You can read all those on your own. Locate on the real z-axis. Yes, I'm going to locate line work on the real z-axis. I've got an option here now that says, instead of just on or off, it says by code. And that's because some codes are going to draw 2D lines down at 0. Some codes are going to draw 3D lines that are drawn between each of the individual points. So I'm going to do it like that based on whatever the code says. Now, the PCPT curve type, that means when you are defining a curve, a curved edge of something, and we usually do that by attaching a code, for, you know, a PC, and then we close it by attaching a PT, so point of curve, point of tangent. How do we want those curves to be? And we have three options. We've got Bezier curves, we've got sequential arcs, and we've got best fit. Now, sequential arcs is the default, and it uses circular curve pieces, right? So it uses 3 points in sequence. So when you get to the first point that has a PC on it, that becomes the first point of the curve. And then it goes to the next point as a point on the curve, and it goes to the third point, and that is the end of that arc. Okay. So field to finish will work by not using PT codes. You can only use PC codes, But when you choose to do that and you do not use PT codes to turn the arcs off, it makes the assumption and it takes the 3 points it finds, starting with the PC coded point, and the next two draws an arc, and then it goes back to drawing straight lines again. So that's if you don't use it. And like I said, I like to use PTs. I like to use the end code, even if I'm only using 3 points. But the benefit to using the start and stop codes is that it knows that every point in between the PC and the point that has the PT on it, every one of those points is along a curve. And that curve can be S-shaped. It doesn't have to look like, it doesn't have to be a fit. You know, it doesn't have to fit into a single arc. Because if I've got, you know, a point like, if I can give you an example here. Let's see if I can. Take that out, and then all right, so here's an example. Whereas I could take this point, let's do a symbol. So if I'm coming along and I'm getting these points and that's my edge of pavement, and I hit this point, I say PC as the code as part of the series of points. Well, then I can start putting points down everywhere along the way as I go. And then I would come to this last one called PT. Then it's going to go back to drawing straight line segments. So all of these points in between are going to be used, and it groups them in threes. When I say sequential arcs, it groups them in threes and makes those little arcs and joins them up together. And if it doesn't have enough, let's say I didn't have 3, 6, 7 points, you know, so it takes these three and then it starts over again to the next three and then the next three. But if I miss one, it'll fill it out and then adjust it out to where it needs to go. So that is one way to do it as sequential arcs. If I do it like this, not sure how to do this. Let me see. If I get, if I can make this happen the way I want it to show it for you. Yeah, maybe. All right, so. All right, so I could have something like this, and that would be like a Bezier curve. And that's not exactly what we've got here, but it represents, you know, it'll fit the purpose of describing it. Whereas then if I've got let's see, let's just draw an arc. And we'll make that one. Right, all right. So this might be the three different scenarios of how you want your system to behave. When we draw a field to finish, so I'll go to survey, draw a field to finish, and I'm going to go to those additional draw options. And when that comes up, let me pull this off to the side so you can see it. The additional draw options, this is the section right in here, PC to PC, PC to PT curve type. A Bezier curve type fit would be that all of these little points, this one starts your PC, this starts your PT, and then all of these other little points would be control points that govern the shape of the Bezier curve. That would be that yellow line that I've done. So all of those little white points might, you know, they wouldn't necessarily lie along the point, along the curve, but they would be something that would more smoothly fit, you know, a fitted curve between the points. And I don't know how you actually use those, because you would be required to go out and shoot the control points in the field. And those are not defined as being on a particular edge or being as part of the arc or part of the curved edge. They're often not. So it'd be hard to do. But anyway, it's an option for you. Like I said, the default is sequential arcs, and that means that every point you shoot is along that arced edge. That would be like the white line that you see. Okay. And that's the easiest to do in the field because it's, you know, you don't have to guess, you know, right where that edge of that structure is that you're surveying. But be aware that when you do that, it takes every 3 points and it actually makes true circular arcs and joins them together end to end, whether they are tangent or not. Okay, so it's not necessary. So if you do more than 3 points, if you shoot the PC and you shoot a point along the curve somewhere and then you get the end point, then that's a definite, and it'll go through those 3 points for sure. But if you do multiples along, even along a single arc, there's no guarantee that that would be, it's always going to group those 3 together.
That's
The other,
actually a better option, right? Because the sequential arcs, I mean, because that's the reality in the end, right?
well, not always, not necessarily, because, you know, if you're wanting, if it's just a single curve, then yeah, but if you're shooting this, you know, this sinusoidal looking edge of something, then sequential arcs, it's going to be, again, they're circular arcs. They're not splines or anything like that. And they're going to be every 3 points defining those arcs, and it joins them up edge to edge, but they're not tangent to each other necessarily. They're going to look like it. You're not going to be able to tell the difference because, you know, when you're out there,
Yeah.
the reality of it is that you're out there on the ground and it's going to look like that. But the other thing is that when you do those as sequential arcs, the arc geometry makes it easier to work with as 2D drawn geometry as part of your drawing, whereas you're not dealing with those weird curves. Now, the third option, though, this best fit is, let me put, that's our default. That's what I'm going to keep it back. But this third option here, this best fit option, That's going to take every point that you shoot out here, and it's going to fit an arc that goes through all of those points that you've observed, such that the departure of those points away from that resulting arc is minimized for each of the points. That's the least squares fit. So it's basically, you're taking a whole bunch of points and you're going to fit a smooth single arc from start to finish through all of those points. Now, that's not a bad option if you're always shooting points that are going to be, just a single curvature. But if you're doing something like what you see on the screen there that has multiple curves connected together, it's best to try to, get multiple points along, get the starts and get the inflection points, get the points of reverse, the point of reverse curve. So I would get the starting point and maybe skip the midpoint, get the next point where it goes to a different shape of the curve. All right. Now the other option is some people will do they'll come up to here at this start point and call that a PC, and they'll get another point and they'll call that a PT, and then they'll do it again, real close by, or maybe they'll call that also a PC, and then a PT, and then a PC, and then a PT. So they'll actually try to observe these three arcs together, where really all you need to do is define the PT and the P, or the PC and the PT. All right, so that's that particular option. Now, there's another sort of a little trick that you can draw these curved structures by coming up here and shooting this point called that's a PC. And then you can go and shoot nothing along the curve and come over here and call that the PT. And as long as you have a point before the PT, so that you're coming into this at a particular direction, and as long as you have a point that goes out of the PT so that it has a tangent direction there, it will fit a tangent curve right between those 2 points. So it'll basically do like a fillet of that as a polyline, okay? So it's a way to sort of cheat and get tangent geometry, but there's no guarantee that that's going to land right on the edge of that curve, because the contractor might have built it non-tangent. You don't know. And your job as a surveyor is to reflect what's out there. So I would always try to get at least the midpoint, somewhere near the midpoint, as a point on that curve. Okay, now the other option that you're looking at here in this dialogue is how to handle these tangent stuff. And that's if you check on that you want to adjust the PC and the PT to make the arcs be tangential. What that means is, let's say I shoot the PC point and I shoot a point somewhere on the curve, and then I shoot the PT point. Well, that defines the arc, those 3 points. But if they're not tangent to the line coming in and tangent to the line going out, but they really, I'm thinking, should be. So what it would do is it's going to slide that PC point up and down that incoming tangent and slide the PT point up and down the outgoing tangent to a maximum distance of this tolerance. And it will make that adjustment so that the resulting arc is actually tangent. So that middle point is always going to stay. It's just going to slide these points down here enough to make that curve tangent to these 2 points. All right. So it's sort of a way to make a little trivial adjustment. And if your eye is good enough to where you know where a curve is going to start and where it's going to stop, you can either not worry about tangency, or you can use this, and usually within, like, you can get those within half a foot easily. And if you have to adjust the point more than half a foot, then you need to, think about maybe, re-observing the point. All right. And then after that, we can create these point groups. You can automatically, by code, meaning it's going to read the code of your coordinate file of all your points, and it's going to create a point group that is that code name, the same as that description on that point. Or you can do it by the code definition so that in your in the definition of our codes, in our field to finish codes, we can tell it a point group to create. So it's going to read whatever group we tell it to put it in there. So you could have, you know, a code that says MH for manhole and FH for fire hydrant and a WV for water valve. And your codes for all of those things might say, hey, put those in a group called UTIL for utility. So if I say do that by code definition, it's going to look up whatever that code says to use and make a point group out of those points. Notice it can also create other groups. So the point MH could belong to a group called util and also belong to a group called MH. FH could also belong to a group called util and belong to another group called FH, because we've told it to also create groups automatically based on the code of the point, not the code definition, but the code of the point itself. And then you can ignore a code suffix, and that is, Brian, the code suffixes are like that that gravel 1 and gravel 2, you know, where you're starting and stopping multiple linear features. That's the suffixing, and you can say ignore that or not. And you could say if you don't want it to ignore it, so you get two groups, you get a gravel 1 group, a gravel 2 group, but if you said ignore it, then they'd all go into the gravel group and be done with that. You can also give a prefix to any of these group names it creates, etc. So it gets all messy. I'm not going to go through all those. And that I will do. Now this pause on undefined codes, that's when you're running this, if you should happen to encounter a point that has a code that's not been defined in your code list, it'll stop the process and tell you that. Otherwise, it'll go ahead and finish the rest of them. You'll just have to go back and catch where the hole is, okay? So we'll say okay to that, and we would be ready to go. Next, we need to add the code table. And so right now I've got a code table that's pointing to auto symbols FLD, which is not what I necessarily want. So I'm going to say set, and I'm going to go to the new tab, and I'm going to call this one, I'm going to go back to my data sets here, and I'm going to call this one F2F dash test. Okay, just because I'm going to start a new one. And so because I'm doing a new one, I get this. Do I want to make a code table? Do I want to start building my code table based on the points that I see in my coordinate file? Or do I want to import? And there's another place. Who was it? Was it Mark yesterday? I was asking how you get those in from your data collector. Right, there's another place you can do that as long as you have that FCL file, the feature code list file from your data collector from SURVEY. Okay, so you can import all those if you want, or I'm going to say code table by point descriptions. Okay, so it's built me that file and it's read the codes in the points and made codes for all of those. So let's go take a look at that next. So I'm going to say okay. And it's going to go on to the next step. You see, it's getting a bunch of, ooh, actually must have done something. Oh, right. Survey, draw field to finish. Yeah, I know what I meant to do. It didn't show you anything any differently because it's pretty much empty, but I needed to now go down and hit edit codes and not okay. I hit the wrong button here. So if I edit my codes, you can see I've got a bunch of descriptions. If I sort, I'm going to click on these titles, I can sort them alphabetically. So I've got a 12P, a 18D, blah, 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 all the way down here. But notice, see, I've got an X, a UP, I've got a CM, So it found all of the point descriptions and started to make some codes for me. But right now they don't do anything other than just draw whatever my default points are, okay? So we're gonna learn how to come back and flesh this thing out to get it to work for us. When we come back, we're gonna stop and take our lunch break now. So let's go ahead and I'm gonna just hit save and exit. And oh, I just hit cancel there. I don't need to draw that. I will save my drawing and we'll come back to this and pick it up and start to see how we build those codes and make them do what we need them to do. And we'll get into some we'll take a little deep dive in a couple of options like on those road edges and come back. All right. So again, being 25 to 1 here, East Coast time, we'll come back at 25 till the following hour, 25 till 2. So it gives you your full hour for lunch. And any questions on anything to this point?
Nope.
Okay, good deals then. All right, so I'll see everybody in an hour.
Okay,
Okay.
all right.
Recording. And we'll pick back up now where we were sitting before. And put that away, and here we go. All right, so what we've done is got a bunch of points in, and we've used the draw field to finish to be able to, we're making a point library, a code library, basically on the fly. We're doing it by reading our points and seeing, from those codes, it's going to create some codes for us, and then we're going to modify those codes to help it do what we need it to do. Okay, so let's go to that step. So let's go back to the survey menu and choose draw field to finish. And we've already set up our additional draw options. We've established our code table. So let's choose edit codes. And now this is where we're going to define what these codes are going to do. And we've got, a thing over here on the left. We can make different categories for different things. For instance, if we add a category and let's call that, say, maybe util for utilities. And then we've got anything that's unassigned, all the codes together, and then everything assigned to utility. So I'm just going to go here and select a few. I know that this one is a utility pole, this. And so if I select that and choose the edit button beside it, or choose the edit button from the buttons down below, I can see here I've got 3 different tabs at the top, and I've got whether I want it to be, processed or not. And over here is a category. So I can assign that to my utility category. And let's just make that the only change I'm going to make at this point. So now when I look at utility, it shows up here. When I look at unassigned, it's no longer here, although it would still show up in all. So I'm going to take that utility and say I've got a fence line, concrete monument, a hub, a shed, an iron pin, some trees, a building, a light pole. That's another utility. And I've got a manhole. So I'm going to control click light pole and manhole. And I'm going to come down here and choose move category. So it's going to take both of those and put them in utility. So now you can see in utility, I thought it was going to. Apparently it didn't. Let's see. Light pole. Move category to utility. Now I've got utility pole, manhole, and light pole is in utility. And you could keep doing things like that. You can make, you know, another category called structures, for instance. And then out of the sign, you could choose, here's a shed and a building. And move the category under structures. So you get the idea. So now you can sort of help categorize your different structures or your different codes rather, sorry. So what we can do now at this point is start to define what some of these codes are going to be doing. And these codes are going to react based on whatever this definition says to do, followed by some particular secondary codes or what are called special codes. And if you look down here on the left-hand side, there is a button that says special codes. If you click that, you're going to see what these special codes are. And these are follow-up codes that you can use to add to your points when you're out in the field collecting them and your description that tell it not, I mean, that tell it some additional information. For instance, I believe it was Mark that was talking about the fire hydrants or something that maybe you didn't want, maybe you're shooting all your fire hydrants on top of the plug. So you don't want that point to be part of your surface building when you're going to make a surface out of it. So you would put in your code, when you recorded that point, you would put, let's say HYD for hydrant, space, this one right up here at the top, this NOS code, the non-surface. So you would put HYD space NOS. And so when the field to finish system reads that point, it will still store the point and store the elevation, which would be at the top of the plug, but it would not use it in a surface. And it would be just as if we had edited the point and turned on that little switch that said non-surface. Okay, so that lets you do it at the time of collection. A couple of others here that you can see, and there's another one here called no elevation, meaning that even though you're observing a point's elevation, if you said no elevation, it sets the elevation of the point in the coordinate file to 0. Okay, so and why it has this one, I don't know if this is in the older versions or not, this yes code for yes elevation versus no elevation. Not sure at all why that's been added. Because all you have to do is just not put the no elevation, and it is by default yes elevation. But anyway, so there are a couple of things that are more commonly used than others. And we have this backslash character and this / character. And the backslash character means you're going to put in your code, and then you're going to put a backslash and you're going to type something. And what that does is it puts a prefix in front of that description. So for instance, if you have a code that just says valve, okay, and you're getting all kinds of valves, water valves, gas valves, what have you, you could make the point as valve backslash water or gas. And then when it puts the description in the drawing, even though in the coordinate file it just says valve, when it goes into the drawing, it writes it in as gas valve or water valve or whatever you put as your prefix. What we also use a lot of is this /, and it just does the opposite. It appends the description instead of prefixes it, it adds to it on the back end. Okay. These other two, the double back and forward is /code. So it prefixes the field code description and appends the field code description. So that would actually change the entire code itself to something as a prefix and a suffix after it. Again, it's not one that's used very often, but it's I'm gonna say, because you could just type in the whole code by itself and not have to put the slashes in. I'm not sure why you would do that. Maybe you wanted it to behave like the base code description, but you wanted to give it a different description. All right, so some of them that we use a lot of, we use this NOS switch on occasion, and then we'll use this backslash and forward slash. You know, it's either come before or come after. Kind of, you just think of the shape of the top of the slash as to where these extra texts that you type in are going to go. And then over on, let's see, down below here, you've got these point symbols and attribute special codes where you can type in different information, like for instance, a size code. So if you're putting in tree symbols, you could put in a tree. If you want to make it bigger than it normally is by its definition, you would put in SZ space, let's say a 24-foot canopy on an oak tree. You might put, you know, oak space SZ24, which means it would draw it at that size into the drawing. Okay, you've got multiple point codes that handle symbol rotations and such, and you can set in these third codes, et cetera, et cetera. So the other ones that we use a lot of are this right here, begin and end. And it doesn't have to be these characters. It can be a B, it can be an E, it can be a, you know, a 7 and an 8. It doesn't matter, whatever you're going to use. But the key to make this work the way it works in the field is that the feature code list on the data collector, you have to use that same code in both of these instances. And so what this does, begin and end, is it starts and stops the drawing of line work between points of that same description. And it works by when you're getting ready to start to draw the line, you're going to put in the begin code after the description. And then when you're through, excuse me, drawing that particular feature, you would put the end code. Now, the way it works, because it gives you some optional behavior, all you have to do is use the begin code, and then every code thereafter gets drawn to the previous point of that same code. If you want to start another line somewhere else with the next point, you could just go to that point and put in the begin code. So it knows to then stop the previous one you were doing at the previous point of that description, and then start a new one when you type begin all over again. Again, for myself, I like the discipline of telling it specifically where to stop and not just relying on starting the next one to imply where it stops. The same thing occurs with these followings, PC and PT, the start of a curve and the end of the curve. And every point in between just carries the description. You don't put anything else on it to tell it that those are points on the curve. It knows it's a point on the curve because it starts with PC and ends with PT. And again, the PT is optional. And if you don't have it, it uses PC and the following 2 points to define the arc, and then it goes back to drawing straight lines. And then some of the others you might see that use a bit is this rectangle code. So that lets you, if you shoot 3 points, you can close it off as a 4-point rectangle, or you can put you can just have 2, excuse me, just have 2 lines. And if you put RECT after the second point and then give it a distance, it defines the width of it. Whereas a 3 points, the width is already defined by the first and second points. Third point defines the length, and then the rectangle closes it off rectangularly. Then you've got some codes here, close. So if you're, say, measuring around the, you know, the shoreline of a pond or something, for instance, or you're getting a concrete pad for something, you'll get the corners, and you call it, you know, CONC, BEG, and that's going to begin drawing the concrete. And then you would say CONC, 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 all the way around to the last point. And you do not have to go back and re-observe the first point. You just, on the last point, you put CLO and it closes it, just like closing a polyline when you're drawing in the CAD system, okay? Then you've got some offset horizontal, offset vertical, offset left, offset both, and you got offset only, so it doesn't draw the line between the points itself. It only creates the lines as offsets. So different behaviors on those. You got CIR that says that, hey, this is a circle, or I'm shooting in the center of a circle, and then you give it a distance for the radius. This one is one that we use a bit, JPN, so join to point number. So let's say you're out there and you've already observed the corner of the house, for instance, and then you're out shooting the power lines out on the road, and you get to the power pole that has the power drop from that pole down to the corner of the house. Well, you'd shoot the power pole, and if you're drawing the lines that represent the overhead power, then you would you would add a JPN and put in the point number that was the corner of the house, assuming you'd already shot it first. If you hadn't, then when you get to the house point, you would put the corner of the building followed by a JPN and give the point number of the power pole. So you can see how that works. So all of these others have some different meaning. Here's another one here called ramp. So if you're doing a lot of like handicap ramps on your sidewalk, it's a real quick way to get those in very quickly just by shooting one point and then measuring the geometry, and it creates it as it goes. Okay, and I'll show you how some of these work. And you can see it, first of all, in that book that I referred you to, that's in your F2F getting started guides. They're defined in there, but if you look in the help system, so I'm just going to come down here and choose help. And I'm in my field to finish section of my help system, and you can see, it's quite extensive. It comes all the way down, and it really shows you everything about, how to set up your coding. All right, so it's really an extensive, documented system on how this stuff works. So as you can see, it can get very fancy. This talking about, we've got these other utility setups and the pipe setups and the topo and the tree and all of that. So, we'll get into those. You can get into those things as a little bit more advanced work. But here's some other examples, and it shows there are a couple of included files, F2F example, field code. Here's your coordinate file. Okay, and they're in your Carlson survey folder, as well as in this data set, I think, as well. And it shows you how to, use close, use rectangle, use offset horizontal, use offset both, offset left, etc. All these different options, okay? And so let's find, for instance, the ramp. It's nuts. It's here, but in field to finish. Draw field to finish. Let's see where ramp is. If you notice it as I'm streaming by here, I'm just looking for that word ramp to be highlighted. It's just so big, it's hard to find these things. I don't know where they are within, but this is how you would look up these things because they'll take extra parameters. You need to know what those parameters would be, for instance. I don't really. Can't really find it there. Let's see if I can find it here. You look under special codes. Special codes, line work special codes. It should be there. Begin in PCPT, blah, 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 rectangle. So you can see in rectangle, if you're using 2 points, you're going to locate 2 points. And then the last one, you're going to put RECT or whatever you've told it to use for rectangle code. And then you're going to put a distance. You put a negative to go to the left. You'll put a positive to go to the right. So in this case, in this example, you see here 110 to 111, you had a BLD and a BLD rectangle -8. So it jumped over to the left because you're going from 110 to 111. It goes to the left 8 feet and creates it as a rectangle. In the case when you have 3 corners, you don't put any distance, you just put rect. So the first point, 110, 111, 112. And so you've defined the 2 edges, you say rectangle, then it draws those back 2 lines to finish that off, okay? And there's your offset horizontals, and etc. There's your join to point name, smooth jog, that's another possible. Here's our ramp. Okay, so let's turn our search light off, let's see. So this will adjust any 3D polylines that you're creating to make a curb ramp, and it looks for parallel 3D polyline for the bottom of the curb, the top of the curb, and the back of the curb. So you need that face of the curb, top of the curb, back of the curb that you're creating as part of this code work. And so the dimensions are going to go in the order of width, depth, and taper. So here's an example. Use BC ramp. So BC would be back of curb, ramp 321. So, well, they're sorry, not back of curb, but they're calling that bottom of curb. That would actually be like what I would call a face of curb, followed by ramp, and then 3 for the width, and that would be the width across, you know, the width of the ramp itself, left to right, as you're going along the back of the curb. And then 2 is the depth, so it's 2 feet back into the sidewalk, and then 1 for the side taper, so it backs it up and puts a 1-foot taper on there. Okay. You've also got, you can use a cross-section template. You've got another one called parking. That's another special code. And you put in, like if you've got a whole row of parking, you would shoot one end of the parking stripe, the other end of the parking stripe, and then the end of the other one. So sort of like a little rectangle, and then it divides those into even spaces in between. So you don't have to shoot every one of those stripes, unless for whatever reason you need to get those exactly where they are. So you can get the idea of how those things can behave, okay? So dive into that help system a bit, help you understand, what these things are going to do. So this parking and ramp, this can be very helpful. All right, so down here at the bottom of this box, there's a checkbox that says append description with auto space, and that's these slash characters where you're going to prefix or affix the description. And if you say auto space, then you don't have to type the space in when you put the slash in, you just put in the rest of the text. Otherwise, you would put the space in there. All right. So now, what do we have? We've got a series of points here, and we'll look at those in a minute here when we get to them. But I know that I've got a couple of things. I've got, say, a concrete monument and So if I've also got a fence line. So let's start up here at the first, let's start at the fence line code. So I'm in my all category here. I'm looking at FL for fence line. You can, I think those are in point order. If you click on the heading of these things here, that will sort them just like a spreadsheet does. But if I look at my fence line, I'm going to choose edit for that fence line, and let's see what this is going to do. So it's my category. I've got it unassigned. I could make a, if I had a different category, I could put it in there. Right now, the code is whatever is being used on the data collector, that when you collect the point, that's what it's looking for in the point description in the CRD file, so the FL. And then I can give this a full name, and this is just for my own documentation. When I see the code table, it doesn't go anywhere. It just identifies it on the line right here under this full name category, okay? Now the description is what gets written into the drawing file as the description in that point attribute. And if you don't want it to actually write the letters FL or something there with the point, then just simply clear that out so it doesn't put anything in the drawing. It still keeps the description in the coordinate file, just not in the drawing. Okay. Then you're going to give it a layer, the main layer that you want this to go on. And by default, when it starts to build these, it just matches those up. So we might put this on a layer called, well, let's do a little more like, we'll call it V-site-fence. So that's survey, site features, fence. All right, and then you can pick from a list, you can set the color, etc. And if you have down below, you see it by default says I'm going to draw points only, but I'm wanting to draw a 2D polyline. And the reason I'm doing 2D is because it's not I'm not going to necessarily get all the little vertical breakpoints along a fence. I'm just going to probably get the fence corners. So I'm going to not be able to take advantage of that as a 3D line, but I will want to see it in my finished map. So I'm going to make that a 2D polyline. And then up here at the top, I could have a separate distinct point layer. So I can put the point on a layer separate from the symbol and the line if I wanted to do that. I'll just uncheck it for now. I'm not going to worry about it. I will go ahead and choose this attribute layout of point, that's that 2. So instead of point number, elevation, description, staggered around it, I like them on the right-hand edge. That's just a matter of preference. I can assign it to a particular group. Remember, we talked about in those additional draw options where we told it to use it by code definition. This is where it reads this and puts it in a particular group if we want it to do so. All right. Our attribute size scalar, that's how big the text is going to be for the point itself. And it, again, is that word scalar. So just think plotted inches at whatever your scale is. And then I want to also locate my points on the real Z axis. Again, here's another place where you could tell something is non-surface. Instead of using the NOS code in the field, you could actually do it right here in the code definition. But I'm going to go ahead and allow it to be used because even though I'm not getting all the points along the length of the fence, I'm still getting points at the ground when I shoot this fence. So I would leave that unchecked. And I've got these feature types: topo, tree, pipe, and utility. Okay. Those things here, the trees, pipes, and utility setups are in, there's some addition. Let's see, if I were to call that, say, a tree, then you would have to go and define your tree setups, and they're over here on the right in this big, in the main definition file, you see those feature settings where you got a tree setup, pipe setup, and utility setup. That's where you define the behavior of how these things work if you've told it to be of that particular type. Okay, so it's just some additional stuff. It's well documented in those extra things I told you to study on your own later. So we'll just leave it as topo. And then, so we're going to draw a 2D polyline. And there's several things we can do at this point. If you go to the symbol tab, we could set a symbol for the point to use. So let's say we're using a fence post and we wanted to use this round circle. So that would draw for the fences or for the points itself, assuming we got, you know, points at the corners where a post is. And then under line type is where you can set a specific line type. You can set it from, you know, whatever list of line types you have maybe here. And I've got these fences. If I go next, let me set my spacing scalar to a 1.5 every 1.5 inches. And my symbols for my X's, I'll make there's 800ths. And then when I choose, I've got a fence that looks like, I'll go next. Let's see, up there's a fence, like a barbed wire fence with gaps. Here's one where the line goes straight through it. And so you got these different type of options. I'll just choose this one and see, now this is a particular special. We're giving it a specific line type to that thing, but not at the layer level. And again, we'll set my line type spacing up to 1.5 and my, if I had text in my line type, I'll make it 800ths. All right, so that should work for that. And down here's where you set, when you're drawing lines, I told you about doing your points in order. There you could do either sequential or nearest found. We typically leave it as sequential, and then their tie points we leave as opened. So that if it does need to close, like we're closing off the end of a concrete pad or the shore around a pond or something, we could tell it to automatically close to the beginning point. But we've got a code to do that separate, so I'm going to leave that as open. You can give it some descriptions, give it a GIS asset definition, etc. You can even define the template. We'll come into that part later. But what we would typically do in most workflows, instead of necessarily defining a particular line type for the code itself, we would usually just set that line type to be by layer. And we would go into our CAD layers and define the layer to show that particular line type. But just so you can see how it works, we'll go ahead and choose that here. And we'll say, okay. So now we've got our fence line done. And the next one down is a concrete monument. So I'm going to edit that. And I see it says CM. And I'm going to call that Conc Mon. As well, let's see, let's call that as a concrete monument. And for the description, I'm going to make it write out Conc Mon in the drawing. I'm going to put this on a layer called V-ZTRL. And I'm not going to draw lines. I've only got the 1 point anyway, but I'm not going to draw lines between them. So I'm going to leave down here to be points only. I'll go to my symbol. I'll choose my symbol by clicking the button there. I'm going to use this square symbol for a concrete monument. And I'm going to make it a little bit bigger than that 10. So I'll make it a 0.15. That should work for that. We'll say okay. And our hub, that's our traverse point. And this is a hub and tack. And I'm just going to leave no description on it. And I'll put this on V-. CTRL dash trav, let's call it. And for the symbol there, I'm going to use my little triangle and I'll leave it as my standard default of 1/10 of an inch. All right, so we've got a couple things there. And let's go ahead and save this and exit and choose OK, and then see what happens. And really the only thing, let me get rid of this mess over here. So the only thing that happened was it drew, let's see, I've got that special line. It created it as individual pieces. If I look at that and I see its length is like a 1.3, so it's like 1.5 feet was what happened, is it created that as all those independent pieces. That's why we normally use that as a, we'll define it as a bi-layer type of definition instead of those special fence types where we build it, okay? But you notice I've got IPFL, so I've got two codes in one point. So the IP code is right now undefined, but the FL is a code for a fence line, and it said to draw it with this symbol here, this circle. So if I double click that, I see it comes up here and it had drawn that symbol in there. It's a block. And if I double click the red, that's the unrealized symbol from the point itself. So that's the actual point, and it has that iron pin and fence line both together. We've got a similar situation up here where we have the iron pin or the fence line, which is a fence post, but we also have this concrete monument. So the point itself was FL for fence line and then CM for concrete monument. And then it has a slash parentheses 4-inch DIAM, so a 4-inch diameter, which we've shown it as a square symbol, so disregard that part. Second, let me send this guy a text that I am teaching a class here. Bear with me a quick second. Messaging Jim. Oh, he probably won't get that. Let me see, try it this other way real quick. Ventura. I'm teaching, can't talk. All right. All right, so sorry about that. Now, so a couple things should have happened here that didn't. The FL made this point to be a fence line first, so it drew that and started to draw the line over to the other FL. Its code was second, which is fine, doesn't matter. It connected those two together. But what happened up here where it says FL space CM is that, remember we made our code CM, we wanted it to write out conc mon, and then it should have with this forward slash then appended parentheses 4-inch diameter at the end of that description. It didn't happen, and there's a reason for that. And let's see what that is and how to fix it. So if we go to survey, draw field to finish, we're going to edit the codes, and we're going to come over here at the bottom left and choose our special codes, and we're going to look at a switch that is in play, and it's right down here somewhere, I thought. Append the description, auto space, no. Let's code table. Yeah, I'm sorry, here it is. Instead of special codes, it's the code table settings button. So what we want it to do is these switches down here are going to have some effect. So we can say draw field codes that don't have a suffix as points only. So that's a way to, if you're not wanting to draw lines, you leave off numbers. If you want to draw lines, you put a number at the end of it, like just whichever one you're working on, 1. And if you're doing another one, 2, like 2 fence lines, you're getting another fence line. But if you don't want it to draw the line work, even though the code says to draw lines, you would have that check on and you would have to only be able to draw lines when it has a number following it. Okay, so we're not going to turn that one on. We're not going to stop any line work at a gap in the point numbers necessarily, but here is where we're supposed to do, let's see, stop. We skip the first or second symbol control when missing the third control. No, we skip multiple Z labels for line work. That's fine. Stop line work for different point groups. It doesn't matter. Use preceding special codes, and that lets you put in your special codes before the actual point code. Interpolate no elevation points for, yeah. I don't see where that's going. I want to make sure up, oh, it's up here now. So we split these multiple codes, and right now you have to have this set in a particular, however you want this to behave. So we're going to use multiple codes. And when it says split the multiple codes, that means when it sees the space between the FL and the CM, it knows to split those, and that becomes a multiple code. If I say none, it's looking for a code that says FL space CM. All right, so we're going to make sure we split the multiple codes here. And now over here where it says use multiple codes, you can have it use it for line work and points, or the line work only, in which case it would only any following multiple codes beyond the first one would only read the line work controls for those special codes, but it would not do the point behavior. And or it could be the line work and then only the symbols for those other codes, but not create the points. So we wanted to say line work and points. Now that should have brought that in. So that should have worked right here. Points only. We got the symbol. I saw the symbol showed up. All right, so let's see if we can do that. Let me fix this fence line type. If we set the line type, let's look at these CAD. Don't have any fence defines. Yeah, I don't have any line types for, here's some fence. There we go, continuous. So fence B, all right, so let's like these. Let me look. Fence B, C, S, and W. There's F, there's B, C, there's W. So fence B, maybe that one will straighten it out. So we'll save that. We'll choose OK, and we'll choose OK. There we go. So now it's reading that, and it made this now a continuous single entity instead of those individual pieces because of choosing that particular that other line style. So that's more about what I was wanting to see, but I still don't see my concrete monument step up in the game. If I repeat this, I don't know why that got unchecked here under entities to draw. So I'm going to draw the points now and choose OK. And now there we go. So now you see it says conch mon 4-inch diameter. And notice there's 2 points. There's this one. So if I go to my points, I'm going to move point attributes with a leader. So I'll move this out to here. And I'll move this one up here. Let's put that a little further up that way. There we go. So I've actually got 2 points here. I've got, and it's the same point. So it's point 1. There's its coordinate file description. Notice it has no point description. There's no description in the drawing itself. Okay. If I look at it here, I'm going to double click this point number 1, and I see that it has, that is its CRD description, and here is the expanded description that the code said to use. Okay. So instead of having to type all that in my data collector, all I did was type FL and space CM slash parentheses 4-inch DIM close parentheses. So that served the function of 2 different points, and it actually created 2 points. And they're both point 1. There's only 1 point in the coordinate file, but it put it in our drawing file twice, and it put it in based on the code definition itself. So you could actually even, delete the one you're not using. I'll take that and just get rid of those attributes there. Now notice when I got rid of the other one, it got rid of that circle, which was the fence iron pin. So if I draw a field to finish and just redo it, you'll see that circle come back, as well as, and notice it pulled out here. So then I could, either suppress one or the other. And that's the one for the fence line itself. So, and that's because I'm drawing the points. I can either put that on a layer or I can freeze it. Or if I go back to survey, draw field to finish, and if I looked at fence line, let's edit my codes, my fence line. I could say, instead of drawing these attributes itself, let's see, if I put them on a distinct layer, then I could freeze that layer. And let's see, can I turn this off? If I said none, no, that worked for the concrete monument. Let me move this back. All right, so there's that. And if I move that with leader and I chose this one, yeah, okay. So when I said none on that other one, so here's the point, but it did not draw the attributes. It did not draw the point number, the elevation, and the blank description, because in the code, when I defined that fence line code, I told it for the attribute format, instead of drawing the point itself there, I wanted to say none. I could have said attribute block, and it's on this separate layer, and then I could freeze that particular layer so that that's where it gets turned off. Okay, so a couple of different ways of doing that. Now let's take a look at some of these others. Here's my hub. I've already created that hub as the triangles. If those were traverse stations done in order and you wanted to see your traverse lines, you could tell it to draw the line work. But right now it's just hub and tack, drawing the symbols. IP, that's our iron pin. So if I edit that code, I'm going to call that an iron pin. I'm going to say that it's found, and I'll just maybe call that IPF instead of set. I'll put that on V dash prop dash mon. So property monumentation, points only symbol, and I'll use a smaller circle here. Actually, no, I'll make it a solid circle because it's, nope, I guess it more likely would be the open circle. Anyway, you get the idea. And yeah, these others are going to be some trees. PL at a point on line. And I'm going to call that point on line. The description, I'm just going to actually call it PT online. B dash prop. And I'll just give it a little X symbol here. And I've got an actual code called X, which is like a spot shot. And that's going to be my spot elevation. But I will make it to have no actual description. And I'm going to do something. I say I'm going to put that on V dash topo dash node. And I'm going to use a different attribute ID here, number 3. So I'm going to get it to twist up at an angle. Points only, and I will also, I'm going to make those as plus marks. So it's going to be like a spot shot. All right, now the PV points, those are going to be my driveway. That's the edge of my pavement. So if I edit my PV, I know that that is pavement. And I'm going to not draw any descriptions. I'm going to put this on V dash site dash EOP. And let's see what I might want to do with that. I'm going to put, oops. I want to create some line works for that. Now, I want to draw the lines down at 0 elevation so I can use that to draw my mapping for me. But I'm going to also draw a 3D polyline so that it serves as a break line when I go to build my surface, okay? And if you're choosing dual lines, up here at the top, you've got a separate dual 3D polyline layer that you might want to use. And I always do a little 3D BKLN so that I know my break lines are going to be up there, and I can freeze that layer off when I go to make my final map. Okay, so, but I will use it to do my modeling. And I'm not going to have any symbol, and my line type is just going to be by layer. That's perfectly fine with what I want to do. And I'll say, okay. And now EP is also an edge of pavement. And that's edge of pavement. Description, again, no description itself, no symbol, no line type other than by layer. But I also want 3D and 2D. And that layer is going to go on V dash site dash EOP. Let's put this one on instead of site road EOP. And my dual, I'm going to also put that on uh, 3D. I don't remember if I put a, I think I just, we'll see. And All right, building. This will be a, I don't need a description. I'll put that on v-site-bldg. And I'm only going to do a 2D polyline on that one so that I may or may not have shot the ground elevation at those points. You could see, so there's no need to put those on different layouts. I'll save that one. Same thing for shed. I'm going to put this one on, again, I'll take out the description. I'll put that on v-site-bldg. No dual lines, just the 2D polylines. And that should work for that. And we'll come back and pick up the trees and the rest of these utilities in just a minute. So we're going to save that and exit and then choose OK. It's going to go back and redraw. Let me I thought I told that fence line not to draw. Huh, I didn't save it apparently, so none. Oh, I know why. I turned it back on so that I could then freeze. Oh, if I freeze that, I freeze the, come on, I don't want to do that. I wanted to freeze that layer. Let me see the layer name itself was, what did I call it? The site fence points. The B site fence points. But if I do that, yeah, it freezes the whole point itself. So to be able to keep the symbol but not the point number and all that stuff out there, you can either separate those on separate layers, or in which case I'm going to just take this one and instead of drawing the attribute block, I'll just put it here as nothing. Save that, draw that, and it will redraw. So now it no longer draws that. Let me see one other. Change the attribute layout in my concrete monument like that. And now one thing that happens, if you notice that IPF, there's my iron pin found, and that's that smaller circle, and that's 0.8. Now 0.8, if I double click it and I look at the point itself, you see it had that IP and FL as a code, but there is no actual point for FL. So if that were not double coded, if it were not also an IP space FL, if it was just FL, let me change that. I'm going to change this to be just FL. And I want you to see what happens here. So I'll say, okay, now I've changed that. I'm going to rerun my field to finish. And so when this draws, So I get the point symbol as my circle, but I don't draw the point number, elevation, and description. And you see it's also missing down here. It's as if there's nothing here, but there actually is. That's an actual point. If I double click it, I see, well, there it is, and it's got elevations and all these different things, a point number, but I don't see that. So that's what happens if you turn off the attribute that you don't want, if you don't want to show those. That's what happens when you set your codes to not draw those. Now, it showed up the last time and it said IPL or IPF because I used the IP code that kept that attribute in there. All right, so that would work for that. So now let's take a look at a couple of other things here that have happened. I've got these points here, these with the elevations kicked up at an angle. Those are my spot elevations, in which case, I could freeze off my point numbers and that would look, very much like a spot shot. And if I freeze off the elevations of my control points, now watch what happens when I click on this one to freeze it. All of the elevations go away, which is not something that I wanted to do, right? I wanted to keep those separate. So if I want these spot shots, I want to be able to turn off the point number, but keep these others, then when we define these codes, we need to do something specific with that, because right now, when I choose, let's see, that was the X code. Right now it says separate attribute layers, and I say none. Okay, and so what that means is it's going to put the point, this block that has a symbol, a point number, an elevation, and a description, that's a group of that and the points. So when it draws it, it's going to put the point and the main insertion point of that on this layer here called VTopo node. But the attributes are defined to go on a layer called, let me back off of here. So those point attribute layers are down here called point description, point elevation, point number, and points. If there's nothing defined, that's where points would normally just go in general. But PNT description, PNT elevation, PNT NO. All right. So if I wanted that to be separate though, I would do this. Let's go to that X and let's separate the attribute layers for points and symbols. And let's choose both. I'll say, okay, save and exit. Now watch what happens when it redraws this time. And I look at my layer list, I'm going to see not only this point description, elevation, and point number, and if I freeze the elevation, it freezes for all the points or everything that was not separate. But if I look down here at my spot elevations that I put on V topo node, if I can get down to it here. V topo node. Notice there's a V topo node description, V topo node elevation, and V topo node mark. So now, if I were to freeze those particular point numbers, and I'll do that with my freeze layer by pick on the view menu or my layers toolbar, then that turns off all my spot elevations, but not the other point numbers. It's kept them along, okay? So now, what else have we got here? We got a couple of things that we're looking at. We've got, let me change our 3D break line to be this magenta color, just so we can tell that, yeah, that's a 3D line, that's a 3D line. There's actually lines underneath it as well, the 2D lines. You can see that if I spin this up, you see the ones that were 2D stay down there, but the ones that are 3D are up in the air around it, okay? So what's a couple of things we could do? We've got a point number 5, so it's obviously drawing this shed down here. But I didn't shoot this back corner, so what would I do with that? Thoughts? Or
You
what
can
could I
erect,
do?
could erect it.
Yes, you put a rect code on that last one. 'Cause I had a 5, a 6, and a 7, and if I added a rectangle code on that, it would then finish that out for me. Okay, that's one way to do it. The other way to do it also is if you don't put the code in the field and you didn't want to edit the point, is you have a similar command on the survey menu called four-sided building, and that does the exact same thing. If you choose that, you do that, it's going to draw it. But keep in mind, that's only, once it's drawn. So if, and that's only affecting those particular graphics. So if you go back and reprocess field to finish, it would not have that completed. So you can do those before or after the fact. That's not a big deal. So that's one thing you could do. Down here's another building, 18 to 19. You can see where the point is out here, and this point is out here because I put my attributes that lined up on the left edge. So I've got those 2 points, and that were part of a building. Now, if I did a rectangle on that, and let me show you another little tool. I don't know if you guys use this or not. If you go to survey and choose field to finish inspector, it's going to give us a little split screen down here. Well, I'm going to look at this shed, for instance. So if I go to, that's point number 5, we can say go to point number 5. So that's a code called shed. There's the instance of points 5, 6, and 7. Here they are, 5, 6, and 7. So if I go to 7, I want to now change its description to from 7 to shed space RECT. And if I apply that and then choose it in my list here, and I'll don't have a raw file up, so I hit OK. Notice it redraws it and puts that into place as if I had edited the point and then rerun field to finish. Okay, same thing down here for 18 and 19, which are my building codes, points 18 and 19. I could go to point number 19, and in its description, I would say rectangle, and I would say minus, oh, let's make it 12 feet. Apply that, choose that, and that would draw that out as a completed rectangle, but I had to have the distance, okay? So if I take that back off for a minute, I'll reapply it so it's just here, and I'll show you one of these other codes. So let's assume, for sake of argument, that when we're out here doing our survey work, wherever we're sitting, excuse me, wherever we have set up with our control points, and we see this house, but we see the house, and we can see the corner of the house here, but the other corner goes up here and it jogs around like this, but I for some reason couldn't get into those corners. Maybe there's trees in the way. There is a tree right there, by the way. Or maybe I just didn't want to shoot all these. I just get 2 points to establish the line, and I'm going to use what are called jog codes, and these are part of those special codes. So I'm going to go down here to this point number 19, and I'm going to say building, JOG, and the various jog codes that we can do are, we just give distances. So if I say, 20, and then minus 20, and then let me see if I don't know if I'm doing it. Go left 20, right 20. Let me see what that looks like before I don't recall. Yeah, okay, so when I said 20 and then left and right, so it's not, so this should be straight 20. So I've applied that. Yeah, so it goes out 20 feet, goes 20, goes 20. Um, so let's go, right 40, right. So we're going 40 down, so right 60. I don't know how long the original was. Okay, that would do it. So I'll get down to the end of it where it says right 60, and then I just type CLO to close. All right, I'll apply that. Say okay, and now voila, I've drawn this house. All I could see were these point on the corner. I could see that point on the wall, but then I walked around and just with a tape measure, just measured off my house and created it based on these jog codes. Okay. So jog, straight 20, left 20. So it's like I'm here at 19, so straight 20, it went straight out to 20, turned left 20, right 20, right 40, right. And when it says right, it's you think about yourself as driving a car along that path. So I'm at 19, I drive straight 20, then I turn left and go 20, turn right and go 20, turn right and go 40, turn right and go 60, and then closed. Okay. So that is a way to handle those things that you haven't measured everything all together. Now, if you need all those points, obviously you're going to get them. And I had a class I was teaching once. I was explaining that to them, and I was showing them how to do this type of edit. And this is also, by the way, very similar to the extend by distance command just out in the drawing. But this one kid in the class had this real puzzled look on his face, and I said, "All right, I see you don't, you're not, you don't really get what I was, what we were talking about." I says, "What? How? You don't understand it." He goes, "Yeah, well, I would be the guy that would have to go around and get all the corners with the tape measure." I said, "But why don't I just shoot the point where I'm there because I got the GPS stick in my hand." He had never surveyed in any other fashion other than with a GPS receiver. He wasn't aware of not being able to see corners. He just thought if he could walk up to the corner and put a stick on it, he would get a number. And so he'd obviously never heard of multipath signal blocks and all those kind of things as well. So anyway,
I'm sure someone who's trying to design something off of that will love it.
oh yes, absolutely. So and in this case, like I said, all of these things, these little shortcuts that we're doing, oops, that's the wrong one. That was 60. It was this one that I wanted to make 80. All of these little shortcuts are not really supposed to be used to create, these shortcuts. We need this information out here. That's going to give us information that we're going to need when we're doing our design work. So especially if you are charged with coming back with what's out there in the field, then you want to make sure that you capture all the points that you can see and get to. But these are just some ways of doing that. All right. So now I'm going to take off these jogs. Let me see here. I went out to jog straight 20, left 20. Right 80. So I'm sitting, I built my house right around my tree, so I don't want to do that. So I'm going to take all of these things off and I'm just going to make a rectangle out of that. So rectangle, Let's go minus, let's go positive. We'll go positive. And 24 feet. Apply that. That'll work, I think. I get a little longer. Let's see if we'll combine a couple of these. I'm going to jog straight up, straight 20. So I'll push it out a little bit, 20. And then I'll do the rectangle. Get it a little bit bigger. And what happened? Let's see, jogged, turned here, straight 20. Oh, I no longer need the distance on here. And it's not behaving. Let's see here. All right, so I guess it has to actually have the point before this rectangle code will work. All right, so if we went straight 20, let's go right 60, right 60, close. All right, maybe that'll keep me off that tree. A little too far. Right 60, right 40. Make that there we go. Nice little square house, that'll work. All right, so I'm going to exit that. And now when I look at these points and I see if I edit my point number 19, it's as if I had edited that point in the coordinate file and put all those particular codes in there. Now, that's not something that, you know, the guy out in the field is going to relish typing in all that stuff in a description field on the data collector. First of all, the data collector may not have as much character space as you need. It could also be, you know, 5 degrees out and he doesn't want to, you know, sit there and fumble around with those with his fingers. So it's easier just to go out and shoot the corners. So you get the idea with that, but you can see some of the flexibility here that we're talking about. Now, because of the elevations, I don't really want to see elevations anywhere on my map. I'll just, you know, freeze that particular layer. I will leave those elevations on because they're my spots, my spot elevations. But now what do I have down here? If I look at these particular points, I see I've got a point 27, 28, 29, 30, 31, 32, 33, and on around 34, 5, 6, 7, 8, 9, 40, 41, 42, 43 to 44. So the first thing that I might want to consider is to close this figure. So let's go back to my field to finish inspector. And that was a PV. And we want to go to point 44. That would be this last one here. And I'm going to type in a CLO. All right, so that's good. We'll make that edit. And then you can make multiple changes and then it will when you choose apply, you'll have that list. You just select the ones you want and then hit the OK button. All right, so we've closed that, but we've got like 28, 29, and 30. Let me exit this and let's look at the points directly. Go to points, edit points. And let's look down here, starting at point number 28. And we see there's a piece, a PV, that's my pavement. So there's, and it says PC. So it came around wherever it started at 27, went to 28 and started a curve at 28. Then it went 29 by its nature, that's on the curve. PV is also on the curve, but then it, you notice it doesn't have a PT here. which if this were me doing it, I would make sure that I started and stopped everything discreetly like this. Okay, but you notice it did not have any bearing on it because it started with the PC. There was no PT and it found another PC. And so it knew that it was not using PT code. So it just took 3 points. And in fact, if I'd had multiple PV points in between the PC starts, it would still only use the 3 points and then start drawing straight line segments again. So if I come down here 34, 35, 36, you can see here's 34, 35, 36, and then 37 to 38. So this would have been the PT right here. I don't have a case. I was going to say it could have had multiple straight line segments. I thought I had some other extra points in there, but I don't. But I was going to show you that it does start and stop the curves, and it stops after the 3rd point if it's not discreetly done. But so I need 38 and 37, 38, 39. So I'm going to put that in here. So anyway, that's just my particular brand of housekeeping that I like to make sure that I do. Same thing when I start and stop a curve, a line work. Now, if you look up here, the fence line, there's no begin point on that. So I would normally have done FL, PEG, and then come down here where it picked up there, and there's IP, and I'd say FL, END. So that would be, again, my type of housekeeping. I like to discreetly start and stop those points, but if you don't, as soon as you use a code that draws lines, it starts drawing. Just like when our driveway down here at PV points at 27, that's when it starts drawing. And it draws all of them all the way down to it runs out of PV points. And that's the one where I hit close. So if I did that, and let's say I had another driveway over here and I started on PVs, well, it would take that last point and draw a line over there to the next one. So you've got to make sure that you choose to start and stop, or you could put a numeric suffix on there. So if that was to be a different one, you could put PV2 and code all those with 2s, and then another one is PV3. And then when you close those off, it puts the stop code on the last point and then frees that up to be used again. Now, I'll save save the coordinate file, and but one thing I want you to take a look at here. Now, here's a point down here called EP. That's my edge of pavement, and in fact, I'm going to call it EP begin. And it goes around and connects up all the EP points. And now there's an EP PC, as it should be. There's a point on the curve, and there's another point. Now, if I look at that, it doesn't have the PT, but this one will have the PT on it, you see there? And so what's doing is it's using all of the points are considered to be on that curve. All right, and it's using it as consecutive arcs. So if I were to look at I'm just going to go ahead and select this guy and get rid of it for the moment. And if I look at this, that is a 2D polyline, and I can see the first arc goes from this first point to the second point to the third point. That is a 3-point arc. And then it makes another arc between this 49 and 50 where it stops doing that. So it just basically continues that out there until it hits that. But it makes it into 2 discrete arc segments. So if I were to explode this, I would get an arc here and an arc here. So that becomes those consecutive arcs, right? Notice it's not tangent. And that may be the case, not every arc in nature is tangent. All right. So what else do we have? We got a manhole up here. We could draw some manholes to create those. We've got UP for utility poles. We've got LP for a freestanding light pole. We've got another UP up here. So UP to UP. We've got our traverse points and we've got our trees. All right, so let's go back real quick and finish these codes up and take a look at one last little bit. So let's edit the UPs. That was my utility pole. I'm going to go to my symbol and choose something that looks like a utility pole. Let's see, we'll call it that. And for line type, I'm going to choose, again, I like set these up a little better, and I want to use that electric. T. And there's telephone. There's an electric. But see that E on it? That means it creates it as entities. So it would be a line, a letter, a line, a letter. And I don't want it to be that. So I want to keep looking for an electric here. Now, normally, again, like I said, I would just simply have an electric line style assigned to the layer. But we'll put it here and see if we can find one. There's electric to C. So that's a C for a CAD type. That's probably the one I'm going to want to use. So I'll use that as my electric, and I'll say, okay. Now, whoops, let me go back to general first. Right now, it's just going to draw points only, so it would just draw the symbol. So I'm going to put a 2D polyline to make sure it goes there. I'm going to put this main layer on B-util-ELEC. I don't even know what, and I'm going to take the description off. That should be sufficient. So that'll draw my power lines, my light pole, and it's a freestanding light pole, so I'm not going to draw any lines. I'm just going to do the points only. So I'm going to come over here and I'm going to scroll down here and find an appropriate little light pole, maybe that one. Let's see if there's one that's a little bristlier. This is the one I was looking for. And we'll edit that. Let's see. Let's give it that. We'll call it light, and we'll use the attribute there. Put it on a layer of v-util, v-util-light. Right. So next is our manhole, and I'll go ahead and leave the MH description to be done. I'm going to put that on v-util-san. My symbol, I'm going to look for inlets and manholes. And there's let's use that one. And line type. And again, we'll leave that as bilayer for now. And I'm going to draw 2D polyline because I'm sure these points are shot on the ground, not, they didn't pop them up and those aren't invert elevations, so I can make 3D lines and turn them into my pipes. I'll say, okay. And let's save that and exit that. Choose okay and have it redraw again. And there I can see that was way too goofy. And it is a line type. Let's see if I can fix that. Let's go to annotate and choose line types, change the polyline line type. Oh, did I screw up I did. Go back to field to finish. Let me fix it in the code. I see what I did now. And
I
that
think you
was,
could change that over in the properties too, if you select the line. And then the spacing should be in the properties.
not, you mean like in my, just in my CAD properties? I
Yeah.
could change the scale, the line type
Mhm.
scale, but I can't change the spacing between here, because that's what it does is when it created that, based on what I put into the code definition, it made a line type and then assigned that in, like I could put that on any layer that I wanted. But
Yeah.
it's with the 0.3, and so here's what happened, and I'll do that and just, I could throw that line style away later. But if I edit this code, and that was my utility pole line type, it's right here. It went every 0.3 inches. I want it to be an inch and a half, and then I'll make that 0.08. And of course, if I wanted that letter to be a different font, I need to change the style of the text style that's called standard. That would fix that. So I'll save that, exit that, hit OK, and now there you can see. So so what happened, even though when I defined it with, when I defined it here, when I went here to set line type, see, I have it here. Okay, so that would be what I would normally do if I'm changing it out after it's already drawn. But then when I come back to here, I neglected to change it here. I have to also change it there. It doesn't carry through, but it uses that information in this spot to generate the line style. But then here I have to apply that again to have it created. So that makes a specialized line style. Now, again, remember we talked about how if we had a particular, say a join to point number, so just go straight to point number 7. JPN 17, except 1 in, apply that. Okay, so you see it drew the line up to the power pole. Now, when I do that, let me get rid of that, and I look at that, you see it is, it's on this layer, VSET, because it's on the layer defined by that 0.7, and it just uses whatever that layer's definition is, and its line type is by layer to connect up to 0.17, and that's okay. That's what I might wanted to have done. If, however, I do this the opposite direction, if instead of 0.7 being JPN 17, if I was at 17 and said JPN 7, I'm going to show you another little trick. Jog straight 20. Let's redraw field to finish. Now this line is on electric and it has the line style. It's just not got enough room to get the pattern in, unless I were to change it to change its line type scale and all of that. But yes, you get the idea. But here's the other thing. You see this little line? Let's put it up 50 instead of 20. And then draw field to finish. So you see it continues with that same line style because I did a jog on it. So that's a way, let's say if you're surveying out here and you've got an overhead power and you get this power pole back here, this power pole up here, and then you know that it goes across the fence over here, but you don't want to go over there and get that pole. You could just give it an extended area, or you could, shoot a spot on the fence that you know it goes toward, but not put a pole symbol there. So if you give those jog codes, you can have it, indicate that it's continues on. You could even make that further, or you could, once it's in the office, just simply extend the line. Okay. Now, what's going to happen down here? There's my manholes. So I could load up I left that as a by layer, which was util sand. Let's go to that. I'm going to look for sand. I line type, and I don't think I've got any sanitary. I don't. I load. GJ. See what's in here. Post sanitary sewer, existing sanitary sewer. All right, so see that now becomes SS with an X on it to indicate that it's existing. And notice it's by layer, but it's labeled upside down here. So you know how to fix those? It's simply, you need to change the direction of that line. Now that line was drawn by field to finish. It gets defined as 52 to 53 to 54. So it goes in this direction. But once it's already drawn, you can simply go down to these polyline utilities and you reverse it. And if you choose that, it's going to reverse that direction. Okay. Now you can also see the symbol is a lot closer together than the ones I use for the electric and the fence and all that, but you get the idea. You can make them whatever they happen to be. Now, here's a case where, okay, now this one's upside down. So how do you fix that? Well, the way you would fix that is simply break this into two pieces, either by exploding it, but that makes it into lines. So I'm going to just break it. I'm going to break this. And I'm going to type F for the first breakpoint. And for the second breakpoint, I'm going to type the symbol at and hit enter. And so now this one goes in that direction. This one goes in that direction, which is upside down for me. So I'm going to reverse the direction of that one. And there we go. All right. So then you can't have everything. You gotta split those up if you need to turn those on. Now, here's the other issue. Do you remember when we got the error on our building our surface where we had crossing break lines? Well, if you look at this, see, there's going to be our break lines, and you see the driveway actually breaks, it crosses the edge of pavement, and they're actually not exactly at the same elevation. In fact, I'm going to select those and put them in my 3D viewer, and let's give that a real big vertical exaggeration over here, let's say of 10 times. And now if I zoom this thing up, you can see how they don't cross at the same elevation. So that would generate an error when I go to model the surface. Okay. So we don't want that to happen. And what should have happened is as I'm surveying this edge of pavement, I should have said, I got up to this part and said, and that one's called, what are these? PV for pavement. This is EP. So when I got to this point right here, I should have surveyed that point and given it a double coded point. Okay, that said EP and it said PV and EP. Now, several ways to handle this. You can, let me freeze off my elevations there. So several ways to handle this is that you can break the edge of pavement here for the road, which I would not necessarily do. You could break this one, which again, I wouldn't necessarily do. And you see 0.33 came all the way out to here. So I really want to add a couple of points into this edge of pavement so that it picks up right where 34 and 33, it also becomes EP points. Now here's the problem. If I simply change 33 and 34 to be not only PV, and it's a PT, but let's say it's also EP. And if I do this one, and I'll put an EP in that one, EP, say okay. And let's redraw field to finish. Now watch what happens. Right, so I get the road in sight. All right, so the road one. So it created it as a separate line, but so 0.43, or I'm sorry, 33 and 34 had that EP code in them, but it doesn't know to draw in between it because the EP, it draws from 45 to 46 to 47. So it's actually starting over again. Remember, I told this point to, I put that begin code on it. So that started again. So let me take that off. And now you should see what I was trying to illustrate here. When this comes back up, it's going to have this line that connects. So 33 went to 34, and now you see this goes from 33 to 34, comes all the way down here to 45, and then comes all the way back up here to 46. So that wasn't the solution by simply adding those in there. So what I have to do is I'm going to start 45 again. It's going to be my start. And 33 and 34 are going to be what 33 and 34 just normally would be. So I'll make that, I'll take out these EPs. So if you ever get a situation like this and you need to come back and fix stuff like this in the office, then the way to do that is, and let me redraw it to get it back. Get the extra line work out of there. All right, so now it's just crossing. And so, but what I want to do is essentially insert the same point as 33 and 34 into this EV or into this edge of pavement line. So I need a point 45. I need a point between 45 and 46 to be these same points. So 45, there's, there's no 45 and a half, 45 and 3/4, but I've got 45A and 45B. So if I create a point right on those corners, so I'm just going to draw locate points. And I don't care what those are going to say necessarily. I'm going to just screen pick a point. I'm going to put it right here. And I'm going to give the point elevation, which is, no, it didn't snap to the elevation. All right, let me go to the insertion. Of 0.34. Try this again. Let's draw a point. And I'm going to make sure I get elevation drawn. Yep. Okay. So I'm going to screen pick. And the point I want to create, now this time I'm going to, I don't have my points snapping on, do I? Point object snap. Oh, okay, it's on. So now the point I want to create is going to be right there. Okay, and that elevation is red now, and I'm going to accept that elevation. And that's going to be EP. I'm going to say, okay. Now it wants to know a point number. Now I'm going from 45 to 46, so I'm going to change that to be 45A. And I'm going to create another one now right at where 33 is to be that elevation, that description, and I need to change its point number now. I finished the creation. It didn't have a conflict, but I'm going to now change its point number to, oh, it went ahead and upped it to the 45B, so that's fine. I don't need to change it. Now, when I do this, because those points are now in that sequential order and I draw a field to finish, now this line starts down here and incorporates those two corner points and then goes up here and starts around the edge, around the other edge of the. Okay. So another couple of things that we could do is, well, we need to get these 18D oak and 18D oak and 24D oak. That's, we're going to set up the tree symbols. So let's go once more to draw field to finish, and we need to change, and these tree codes are done sort of oddly. They're done different ways because they're showing you, I guess, the flexibility. But I've got 18D, 24D, and 12P and 8P. But so 18D is simply indicating an 18-inch diameter tree, a 24-inch diameter tree, but then a 12P and an 8P are representing a 12-inch diameter pine and an 8-inch diameter pine. So it's a little odd the way they've coded these up. So if I edit my 18D, now notice the oak, that was because that point is coded 18D/OAK. But 18D, I want to be no description, or let's see, yeah, let's do an 18-inch 18-inch oak. And we'll put this just on the site veg. Let me put the site veg. We'll go to our symbol and we'll choose trees. We'll choose let's use this tree and an 18-inch and 24-inch. So let's make um, point, make it a 1/4 inch tall. If I'm at 30 scale, so 1.5 foot, that would be 30 feet. 18 inches, where's the 18, so 30. 18 divides 6. Let me see. All right, 18. I don't want to certainly draw an 18-inch. So let's just we'll keep it as a 1/4 inch there. So that'd be a 1/4 inch tall for an 18D. A 24D will be the same. So there's going to be an oak. I think we use this, and we set the symbol size up here. Let's make that 0.5. And what else do we have? We got the 12-inch pine. And we're going to just call that one a pine. We'll set that on the site PGE. And we'll use this as that one at we got 12 and an 8, so we'll make that 1.5 and an 8. We'll call that one an 8, and we'll just call it a pine. Make it 0.3. And now the 24D, I forgot to change its description to 24-inch. All right, now I think that's all we need. We'll save and exit. Let it draw. So now I've got an 18-inch oak, an 18-inch oak, a 24-inch oak. And apparently I put that on, forgot to change the layer. It went on layer, whatever that default was set up. So I needed that to go on V site veggie. I would fix the code for that. Now there's your bigger pine tree, your other pine tree. We don't, it used a code of 8P and 12P. If you needed it to save, you would have put in the 8-inch pine, 12-inch pine, etc. Okay. So all of that's done. It's ready to go. If we look at this in our 3D viewer, these are the things that would be, let's take our vertical exaggeration back down for 1. So this is what would be used to build our surface. Okay, so it would be giving us a very nice start. Let's do one other real quick thing that we can do with this line work. This particular code of EP. Right now, it's just drawing a 2D line on the bottom down here and a 3D line up above it. But let's say that we were a industriously lazy surveyor and we wanted to shoot this edge of road and do something a little, let something serve a lot more than just as an edge of asphalt. So that's our EP code, and it is right here. So I'm going to go here to the line type, and instead of just being that single line, I'm going to come down here to the bottom, and I'm going to choose template, I'm going to select, and I don't have one there. If I edit, will it let me save it? Yeah, maybe so. So I'm going to go to new, keep it in my folder, and I'm going to call it wacky EOP, just for yucks. And right now, so the point that we shoot is that back point. So I'm going to say, I'm going to add a grade section. I'm going to add a slope of 0 of 1/2 foot. And I'm going to call that my TC, my top of curb. Oh, wait a minute. I'm going to uncheck this. There we go. So right side, same as left. This I want to remove. I want to define it the other direction. Let me see here. Right side, same as. I want to define it over here on the right. If I add, all right, 1/2 foot, my top of curb. There we go. And then I'm going to drop it down 1/2 foot. So I'm going to add again. My slope is just going to be a vertical drop of 1/2 foot. And the horizontal distance, now remember, I can't have a completely vertical. So I gotta push it out just a wee bit. And that's going to be my face of curb. Oh, I gotta put that negative. And then I'm going to put a gutter pan on. So I'm going to add, let's make that say a 4% of 1.5 feet. And then that's going to be my, let's just call it gutter. And that can be our curb structure. Now, just to make it absurd and to earn the name of wacky edge of pavement, let's say I'm going to add then the travel lane, which is going to go at a slope of 2% for 12 feet. And that's going to be my center line. And then I'm going to go down the other side. I'm going to add another one of -2% for 12 feet. And I'm going to call it EOP-R for the right-hand side. And, you know, I could keep going on and on and on. I'm not. I'm going to say save. And okay. Or save and exit. And now say okay. So I now have a template that is going to be created when this gets drawn. So watch this. When I say okay, now you see this down here, and now it only creates the 3D stuff. So if I pushed, oh no, I'm sorry, it did also create the 2D along with it. So that's fine. All right, but now when I look at this in my viewer to get a look at what it looks like, you can see with just by surveying the points on the back of the curb, you see, I went ahead and now obviously, you know, you wouldn't want to drive up and jump up over a curb to get in your driveway. You get the idea, right? So it's created that entire 3D structure, the center line up higher, and it comes back down on the edges of the road. And now finally, if we were to model this, got those points, everything's good to go there. So let's go to our surface menu and choose triangulate and contour. And I'm going to choose to write this triangulation file. I'm going to choose that. I'll make sure my data set, and I'm going to put in here as my F2F-EG, my field to finish existing ground. Everything here should be okay. I'm not going to use the inclusion. I'm going to let it do the shrink wrap. Let me see what else I might want. I'll actually turn that off so it'll generate contours in here as well. I'll draw the contours, little 1-footers. Let's turn on some smoothing here, just even though I'm not a big proponent of contour smoothing. Future ground, so I'm gonna make that V dash topo and D dash topo. I will label them on V dash topo. Hide under, but not break. Distance will be, let's say, every 250 feet. Make sure under my selection, I don't have any of these things filtered out. I'll say okay. It asks me to select entities, reading the line above, select the points and things because it's all going to be done. I'll say there to there, and there now is my surface file. And I could have, let's see, if I do that one more, I could do it another, I could generate the boundary and then use this to block that off. This is valid, that's a driveway, that's a house, so I would really need to make that as a exclusion triangle. And there's several things you can do it. If you could just trim these lines, and all it's doing is trimming the lines. It's not actually trimming the surface. It's not cutting the surface out. But you could have pre-done that as, if we do that one more time here. If I use inclusion, exclusion, let me see if it's going to let me. No inclusions and then exclusions. I'll take this and this. And now let's see what that does. Does it? Yeah, there we go. So now it's made that. And if I look at my items in 3D, and if I then add my surface to it, come back and turn that on. Solid. Adjust my shadows a little bit. It's not really something you can see very well. Except down here at the road, you'll be able to see that curb edge. And should be able to see those where the contours cross. Now, if you notice where those contours came across and crossed over those curb lines, which are, you can see the curbs are nicely defined, right along here, along the edges of the curb. But look at the contour lines where they do that. You see how sort of, they're sort of goofy and round. See how they're sort of roundy looking as they cross over these edges? And those are really probably because they're nice hard edges. They shouldn't be all that rounded. And the reason for that is simply that we turned on that contour smoothing. So what I would do in that case really is go back to my surface menu, and I'm going to contour from tin file. And I'm going to choose that same file that we had. Make sure it's going to erase those previous ones. Everything's here, but I'm going to turn this smoothing off. And we'll say, okay. It wants to know any inclusions, which I'm not using, any exclusions, which will be that one and that one hit enter. And now, of course, they're choppier there, but they're nice and crisp as they come up here, go across the back of the curb, walk down the face of the curb, come up the gutter line, come to the crown of the road, go to the other side, the other edge of the road, okay? So as you can see now, it took us a little fiddling around, but it's not all that much of a effort. Let me change the surface a little bit. See the contour lines a little better. I don't know. There we go. Yeah, I wanted to see the see the contour lines stand out against it. So you can see, you know, that's really well defined along these edges, you know, right as it goes across the flat top of the curb, walks down the face of that curb all the way up to where it comes out, comes back up to the edge of the gutter pan, comes up to the center line and goes back out the other side. You got this little points up here on the hill, and there's your little site plan that you were able to do. Okay, so obviously your work's going to have much more complex sites than that. You're going to have long stretches of highway maybe where you're picking up, you know, edges and cracks in the pavement and all of that kind of stuff. So the key to all of this then is to make sure that you, as you start to use this field to finish. Now, Brian, you and Gonzalo, I guess, have been using this for a while, but for Mark and Julio and you folks, it's going to take a little bit of an evolution. Okay. So you're going to have to be constantly developing this library and figuring out how to do this and what you should code into the points out in the field so that you're bringing this in as you go about it. Just like we talked about down here when we shot this point that said EP, and we wanted to, and we walk along here and then maybe we pick up a fire hydrant and a manhole and stuff, and we get to the edge of this driveway. Well, we don't want to set it up like this did it, where we just trace this driveway around all by itself and then we run past the edges of it. So when that point right there is a common point to share those features, then just shoot it and give it two codes. You know, give it an EP and give it a driveway edge. In fact, I would have done this as a instead of coming around here and going back across and coming around, I might have started here, come around here and stopped, then started over here and come around here and stop. Okay, instead of trying to do that as a closed figure. But you can see that was, oh, by the way, there's one other thing you can do on that we finish. So if you do a lot of concrete shots and you're generating concrete and you want to close those off, let's look at this PV. If I go to my symbol, I go to my line type. If I hatch any closed areas, when I hatch them, they find something that looks like concrete maybe. So conc. Conc, that'll work. No idea what this scale is going to match or not. I'm saying, okay, save, exit. Okay. There we go. So now that actually put in a hatch as part of the code because it was closed. I could have done the same thing for these buildings, you know, when I closed those because they're closed polylines. So you can have all that, there's a whole lot of stuff that you can do. So I would recommend, as you evolve in this usage, get into that help system, get into the videos on YouTube and try to see how, because you can make this very sophisticated as you go through this stuff. Now this, oh, that's a contour line. Okay. The last thing that we did not do, there's an IPF and there's a point on line. Let me freeze off a couple of those. Let me see. I'll freeze traverse stations. All right, so we didn't actually do the property line, but it goes to this iron pin found down there, down to this corner, iron pin found. And then you can go up to this other iron pin found, and it's probably going to match go around a curve to match the road, but this is, such a simple little example. We don't know what it's going to be, but if we did, let me show you what that would do. IP space PC. And this is going to be another example of some of this optional stuff. And this is going to be IP PT. And notice there's no points in between the two. Okay. So that's going to require a point behind it to go through here to establish the tangent direction. And then it's going to come out here and then come back up to, should there be, and that's 0.1. That's not also an IP, but I'm going to add the code in there to JPN1. I'm going to join the point number 1. And let's go back one last time to draw a field to finish. We need to edit the IP code. And it's going to be a 2D polyline only. I'm going to go here. First of all, let's come back here and take the, that description's fine. All right, so take the line type. We'll keep it as by layer, and it's on vprop mon. Let's make that on vprop PL. Let's call it. We'll go to line type, and we'll just make it by layer. And I think that's the. There we go. And now let's fix that layer, which was PL, vprop PL. It'll be white. Give it some weight, make it phantom, which we'll have to load apparently. PH. All the phantoms here. And we'll assign it as phantom. And off we go. And there's now our property line. And there you see your point on line is right there. Let's freeze again the point numbers, the elevations, those point numbers, the control points. And yeah, there you have it. And of course you can play with colors and do all those things. Oh, and I would also at this stage freeze the 3D break lines, and I would make, that particular line, I would, find the 2D equivalent of it and turn that into a this one only had, let me see. That is down to 0, but it's still 3D, so I would turn that into a 2D. 3D to 2D. I think that's all I need there. There we go. And then I would make, oops, retain elevation each from period. No. And then this, I would set to be a center line based on its layer, or change it here again. 1.08. C, circle, 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 circle. This is not loaded in. Oh, there it is. See if that worked. Well, I wouldn't label it like that. I would just make it a centerline type, but you get the idea. So, there you can have that. Once all of those things are known and defined, and you start to become consistent with this as you bring these things in and out of the field, it takes very little editing when you get them back to the office to come up with your finished drawing. As an example, to sort of let Mark and Julio know, some of the characteristics they might be able to look for. Brian, what would you say? Give us an idea about how much time you spend when you get a point file in and you're building like a simple site, maybe something along this same size, but obviously it'll be a little more complexity. But about how long does that take you to go from that to a finished, at least something finished that you can work with?
Well, we build things out in like 3 different ways. So every field day, it's anywhere from 8 to 12 hours in the office. So if we have, a 10-day job, we'll have like 100 hours in drafting and boundary research.
Well, yeah, but you're doing boundary work, you're doing, the deed stuff, but I mean, just to
Yep.
come up with the base drawing, just the existing conditions drawing. Let's say you're doing a construction site and you're just getting the base drawing that you're going to hand off to the engineering company to design their stuff on.
A lot of the ones we do are like schools, so we're doing like 33 acres, or they're fairly big. Something like this, I'd probably give to one of my survey techs for about a day.
Yeah. So that's what I'm talking about, is the kind of time that you can save using field to finish once it's up and running. Now, I'm not going to lie to you, it's going to take you some time to develop that library. But start the same way we started here. Let the points that you're going to use that you've got in a point file, bring that in and let that create a base level library, and then start tweaking those codes one at a time. And you're going to be back and forth and back and forth and back and forth. And it's going to take a while and you're going to get frustrated, but don't give up, because it's going to really pay some dividends, right? I would think, Brian, that you guys could vouch for that you're going to really see some
Yeah,
nice.
if the field crew does a great job and their cross sections are done how they're supposed to, and their shots and everything comes together well, I mean, we could even do it in a half day. Utility compilation involved, and it saves a tremendous amount of time.
Yeah. So there you go, Mark and Julio. Don't give up on that and just really get into it, because in my opinion, that is the single greatest efficiency increase that you're going to get out of this software, is if you can really wrap your hands around that field to finish and let it generate this work for you. So, it builds the break lines. It does all of these things automatically. You don't have to sit down and play connect the dots. Notice I didn't do any connect the dots on this thing at all. I let field to finish draw everything here. I didn't draw any lines, right? You didn't see me drawing.
Yeah.
Uh, I would fix the code to put that on the right layer. Like I said, you're gonna have, you know, back and forth and back and forth. So just don't give up on that. All right. All right. So let's take a real quick break. That's maybe instead of a full 15 minutes. Let's come back at 5 after, and then we'll wrap up. I want to get into some of those deed tools, and that should give us about all we can stand. And then we'll go out and have a nice cold one, being Miller time and all that.
Sounds good.
Okay. All right.
Okay, okay. So you guys back at 5 after.
Thank you.
Okay, I'm back on.
I'm
You
here.
guys, okay,
Yeah,
Brian?
man.
All right. So, one other last really quick thing I wanted to show you about. If you look on the page 70 in your book, there's a nice little wrap up to the field to finish discussion, and it's an example of doing this now. Now, what we've gone through here before is to help us to build stuff. We got an increasingly extensive library of codes that we're building. But if we sometimes we can use it just to help us get some work done. So if I just start a new drawing. Let's see here. Whoop. As soon as it gets through thinking, and I'll go to my folder. I'm going to call this one F2F dash on the fly. And let's make it, say, 30 feet. That's all well and good. Boom. All right, I'm going to go to my points menu, and I'm going to say import a text or ASCII. No, I'm sorry, I'm not. I'm going to go to points menu, and I'm going to set the coordinate file. And I'm going to choose an existing file in my folder called mantopo and open that. And then I'm going to draw locate my points. And I'll just use these points here, and I'll just put them on V node is fine. And draw them all. Bada bing, bada boom. And there they go. All right, so I got a bunch of points here. And these are, if you see in your book, there are a bunch of points out in a field. That is like a little well pad or something that got constructed, and it's got a bunch of points that were shot out here. And if you look at the descriptions in all of these, you can see I've got a bunch of points in the interior that are called ground shot. I've got some points called 17s and some called 18s, and that's the only descriptions I've got. If I list my points, you can see those. I've got 17s and I've got some join to point numbers begins and all that, but 17s and 18s, but there was no codes. Now, we happen to know, though, that the, from the folks that gave us the coordinate files, that the 17s were our top of bank and the 18s were the bottom of bank feature. So let's use field to finish to draw those lines so that I'm not trying to find all the 17s and start, draw a 3D polyline from point to point to point to point to point. Let's just let field to finish do it for us. So I'm going to go to survey, draw field to finish. And I'm going to choose a different file down here now for my code table. I'm going to choose set and I'm going to make a new one. And I'm going to call this one F2F-OTF for on the fly. Okay, and I will take it code table by description. I'll say okay. And well, it went straight to it because it's using those begin and end codes. All right, and I've got, if I were to take a look at my draw field to finish, unless I happen to pick the same file, I think I'm, no, points only, but it forced the line drawing. It forced the line drawing because of this right here, if I edit my points, because of the BEGs and the JPNs. So it generated all of those. So there's now a begin. So it ended the 17s, it began the 18s, and begin 17s again, and end 17s, and then it had some of these other points. All right, so I don't really care about all of that and what it shows and says, but I actually got, and I think, did I do this as, no, all right, so that was what. So those begin and end codes started the draw themselves, but okay, so those are 3D polyline. I can see that because of the way there's something amiss. Yeah, not, but I guess these elevations are so small that it didn't look like. So these lines are just the 2D lines. So that begin and end point. So if I were to do this now and let's build a surface of it so we can draw our surface file. I'm going to triangulate and contour, and I'm going to call this one my pad-eg. I'll go ahead and draw my contours. I'm not going to label them, I'm just going to draw them. Triangulate and say go. And come back. Let's not do that. There we go. And we'll say that. We'll say that. Now. All right, so there's my contours. What happened out here? Look at that. In fact, if I look at that surface, that's going to look really goofy. Right? And I've known people that will turn that work in. So it's not at all what that looks like out there because we didn't get our break lines done. We got them drawn, but they were drawn in 2D. Okay, so I'm going to now select these contours and get rid of them. That was my draw by layer. And I'm going to actually get rid of those 2D polylines as well. I could have let field to finish do it, but now, so what I want to do then is I want to edit that field to finish code table that we just built. And instead of just letting it create those 2D lines with the begin and end codes, I'm going to come down here and change this from points only to be 3D polyline. And I'll even put it up on this layer called 3D-BKLN so I can freeze it off layer. So that's for 17 and for 18, the same thing, 3D polyline. I'm not even going to bother drawing the 2D polyline, and I'm going to put it on 3D-BKLN. Say okay, save, and exit. And now when this draws, I should see those show up at their right elevations, which you can see now as I look along this edge. You see how they're actually going through the points themselves, okay? So back to my most recent triangulate and contour, we just hit OK, overwrite the original, grab our data, bada bing, bada boom. Now look at these contours, how they draw in there. And let's freeze off a couple of layers here. I'm going to freeze all these points. And let's freeze the 3D break line layer, okay? So now my contours look much more like what I would expect them to look like, these nice little ditches. And if I look at that surface in my 3D viewer, well, notice the difference. Okay, so that's an example of just real quickly using field to finish to help me draw all of those you know, the break lines on the bottom of slope and top of slope. And now what made that happen was the fact that these points were consistent. All the 17s were bottoms of slope, the 18s were the tops of the slopes, and then the other points up. So I didn't have somebody out there, you know, one guy doing 17, another guy doing BS, another guy doing TOS and TS and that kind of stuff. So as long as that data is conditioned, you can use that to very quickly help you create this. And that would have been tough to sit there and try to click your way around drawing that break line, right? So that's an example of using field to finish for more than just doing a finished map. All right. So now with that, let's back up to our deed processing. So I'm going to skip over this first little exercise that is draw. It basically takes a description, a typed description of a deed, and extracts the calls out and creates the property for you. The tool does work, but let me tell you that it's sometimes easier just to code the darn thing in, because you have to go through and let it read. And if the deed description is written where, like, sometimes they put an N, sometimes they spell out NORTH, sometimes they'll use a degree symbol, sometimes they'll type DEG. And if it's not consistent all the way through, it blows it up every time. You have to go through and fix all these. You see these warnings down here: while reading line at position line 4, column 39, found a line prefix with a value of thence, searching for a distance, you know, so it needs to have consistency in those descriptions before you can actually have it convert the text into your map. So that part's sort of tough to do, but we're going to enter our deed. So we're going to, so our deed reader. So we're going to make a new drawing, name of our choice. So again, new drawing. I'll use my National CAD Standards survey. Set up in my folder. Call it deed. If I can spell it, deed processing. I'll just leave it at 50. And that's okay. Oh, no, it's not. Let's call it deed work. And we'll take the default here. We're going to get a coordinate file of the same name, but no import. It's just going to be empty. We'll say next, and off it's going to go to start our drawing up. Now, I think Samantha was telling us yesterday, I think, that, you just use the CAD tools to draw your properties up. Is that correct? Just like drawing polylines?
Yeah, personally, I don't do drawings. I'm in the fields,
Yeah,
like
okay,
maybe 98% in the
all
field.
right.
But Julio's in the, he put together all the surveys and spit out a lot of beautiful drawings.
Okay, all right.
So I'm, I'm
So what,
trying to,
yeah, what I'm getting down toward is we got about 10 minutes left in the official length of our day. I'd be glad to
Yeah.
go later if you guys want to see these tools, but I also don't want to go over old ground if you guys are always doing it. Because Brian, I know you said you do some deed correlations. Um, do you build your deeds? Do you actually, type in the calls around the deeds and then save them as deed files?
Yeah, so I'll draw it out, line by angle and distance by the quadrant, the bearing, the distance. I'll build my curves out. I'll make sure it closes, and then I block it, and then I'll save it based on the plan number, the booking page, and
Mhm.
then I piece it together. Once I have it pieced together, I make one larger block, and I take the field work locations and I'll create calc points for all the where the proposed monuments were, and then I'll do a deed correlation and do the survey points and the deed points and do a best alignment, and then I hand it off to my PLS and she'll make the final decision based off of the importance of each monument and
Right, right. Um, when, but when you're drawing the deed up, how do you do that? How do you do it in your workflow?
I do draw by angle and distance.
Under like draw
Kogo,
or Kogo?
line by angle and distance.
Okay. So, and where is that'll work? Like right there, you're doing that, right?
Yep. So I select that and then I
Yeah,
just pick a starting point and then it's the quadrant, the
right.
bearing, and then
Yeah. Okay.
distance.
All right, so that works. So maybe you can get some mileage out of this as well, because let me show you what this can do for you. Just like we were doing Kogo commands and we can save the raw file, we can turn the raw file on and sort of save the audit trail. If you look under survey instead of Kogo, but survey and choose let's enter a deed description. Okay. And so this is going to be you can give it layer names. We'll just leave the defaults there. Traverse by bearing. We'll use points, we'll label the lines and arcs, and this deed name, let's call that, lot 137, or it could be, Smith and Jones at Ux or whatever. We'll draw the line work, we'll create a polyline, we'll prompt for descriptions if we need to, and then down here's the key. We're going to store this to a deed file. And the file I'm going to use, I'm going to do my set button. I'm going to come down here and choose my folder, which I'm right here in this. And I'm going to call this my file called deeds. And I'm going to say, okay. Now what this is going to do is it's going to ask me to pick a pointer, a point number, just like I'm drawing a line, just like you would do it as well. And I'm going to be putting in this deed right here. And you see my POB is right there, and it's going to go around this direction. So I'm going to go, actually what I'm going to do is I'm going to put this over on my other monitor so I can see the darn thing without having to keep switching back and forth. But if you'll look on page 72 in your training guide, that's what I'm going to be keying in. Okay, so I'm going to, and you'll see how this comes into, it's going to slip right into what you do with your deed correlation. So I'm just going to click a point, and it wants to know a description. I'll call that POB. And well, there it is. It drew the point. And now it wants me to either exit or put a curve in or select or choose bearing, and that's in angle brackets. So that tells me that's the default. So the bearing code is going to be Q, which is my quadrant code, 1, 2, 3, 4, which is northeast, southeast, southwest, northwest around the circle, dd.mmss. So from that POB, I'm going northeast. So my Q is 1, my degree is 25, my minutes is, then I put a period 3045. Oops, I put too many periods here. 125.3045. That's northeast, 25 degrees, 30 minutes, 45 seconds. I hit enter. And then it wants to know the distance. Now the distance, you can see all those other things. Now, we in the Northeast, we're going to be mostly working in feet, obviously. But a lot of guys, like if you're down in Texas, I worked down there for a few years after college. You know, we had deeds that were done in varas. You know, it's a Spanish measurement, and you know, you could get really old things and get rods and all that. So it will convert all that for you. But in any case, here's my 165.45. 45, I hit enter. All right, so now off we go. We're starting along our way, and it wants a description there. I'm just going to call it COR for corner. And okay, what's next? The next is, and it keeps the default, you know, from the previous one, but we're going southeast 45 degrees. So southeast is 2 is my Q. My degree dot MMSS is 45. I don't have to put the period 0000, just take 245, and I'm going to go 200 feet. All right, so far so good. I'm going to now be going southwest, which is 325.3030. 156.78, 156.78. Okay, now I'm getting to a curve. Uh-oh, I did something way wrong here. Let's undo. All right, so from 2, I backed up to 2. I'm going to go to 245, 200. Oh, it was the description. That's what I overwrote. Okay, so COR. Now I'm going to go 325.303, 156.78. So far, so good. I'm now hitting a curve, but I need to put in my description. So there's my COR. Now I'm getting to a curve. So I'm going to type C to curve. And you can do these by a number of ways. You can enter a curve calculation. You can do a tangent out direction, or by radius is the default. So that radius, and that when you choose that radius to enter the distance, and I'm going to say a radius of 200 feet, it assumes that it's coming off tangent from the previous line. Okay. So if it's non-tangent, you have to do something a little bit different there. So now which direction might it going? Left or right? As I'm going around it, I'm going to the right. So that's going to be either the plus, or you can click it with the mouse, or you can just hit enter because it was in brackets. And now it says, okay, non-tangent. That's the way you can do a non-tangent curve. You can reverse, give the reverse tangent, give the bearing, give a chord, a delta angle, a tangent, or an arc length. Well, my arc length is 175 feet. that's in my angles, so that's my default as to what I type in here, 175. There it is. Again, I'll call it COR. And next I'm going to go up. My quadrant is 4. My degrees are 10. My minutes are 15. My seconds are 25. And my distance is 200. And that's another COR. Okay, and now I'm ready to close, but I want to put in the deed call so I can verify my closure, of course. So I'm going to go to my quadrant is 1. My degrees are 25.4030. Hit enter there. My distance is 49.30. Hit enter there. And now that's done. I'm going to say back to POB, and I'm just going to put a -2 on it so I know when I'm closing it up here, and I'm going to hit enter. And now when I'm done with entering all this text, I can type the letter E to exit. That's one of my options there. And so when I do that, it's going to now select the entity for the area. Calculate. I don't know if it's going to let me do that. Maybe not. Okay, so it wasn't closed. Now let me type this UCS. I'm going to turn my UCS icon off so we get it out of the way. All right, so if you see what I've done, I've actually been, it labeled it as it went, it created all these points, and so and you can see right in here when I zoom in, there's my misclosure, so my deed comes up to here and misses my starting point by that little bit amount. So that would be deed misclosure. So, that's again something you're going to work out by other means. Okay. So now, once that's done, or let's say I had put something in incorrectly, because we did it with that command under survey that said enter a deed description, right down below that, 2 things is process deed file. So if I do that and I go to my existing, there's my deeds PDD, and there's that file that I did. Now it can have multiple parcels in here. So Brian, that's what I was talking about. If you do one and you say you make it into a block and then you put them all together and you make a bigger one. Well, this file can hold all of these as individual parcels. And so I'm going to now edit this, and I get a little editor and a picture here. I can look at my angles by azimuth or bearing. I can use a 3-column angle format. So there's degrees, minutes, seconds, or I can use a 1-column where it is in the original form of quadrant instead of my quadrant like this, and blah, blah, blah. You can force curves to be tangent. You can change any of these. So if you mistype any of this stuff and you come up here and it doesn't look like you expect it to look, use this to go back and fix something. And once it fixes it, then when you come out of this, you say, okay, then you can save that. You can draw it. So if you don't, if you're in another drawing, you can load up this deed file and select out any of these individuals and draw them on the fly. Okay, you can run the reports. Here's your report. There's your misclosure. Okay, so it's 0.01 feet along that direction. Gives you your areas and perimeters, et cetera, et cetera. So these are a little bit better than just using Kogo to draw your lines, although, whatever you're doing is fine if you're, if you find it efficient. But this gives you a few extra tools that you can work with. So now this export, I have no idea what the export to a raw file. Okay, I see. So that would save it into a raw file, but I'm not going to bother with that. All right, so once that's there and you can save and exit, you can have these, again, have multiple deeds. And even if you're in another drawing, you have a drawing, you can select select it and choose draw, and it'll draw it out over here, and you can have it label it and all that kind of stuff. But anyway, we've got that there. Definition, okay, sure, save it, saved. All right. So now here comes the deed correlation part. I want to I'm going to copy this boundary off to just to another spot here. So I'm just going to select that polyline, and I'm going to choose just a standard CAD copy command. I'm going to put it over here to the side, and I'm going to then select it. Let me do one little thing here. I'm going to select boop, boop, boop. There we go. I want this one. There we go. So I'm going to select that and just put it back on that closing line. And I'm going to do a couple of other little tweaks here. I'm going to just pull a point just slightly off. So I'm skewing some of this shape a little bit here. And so what I'm going to do with this is we're going to use that to create some points to represent maybe what you might find out in the field. Okay, so I've sort of made some very slight positional errors on this, or and I'm going to take this now and I'm going to rotate it so that it doesn't have any bearing on the rotation. So I'm just going to, give it a slight rotation there. And I'm going to now go to my survey, or my COGO menu rather, and choose create points from entities. And since I started with 1, 2, 3, 4, 5, 6, and blah, 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 I'm going to make these we'll call these FLD dash node. And I want to uncheck that. I don't need the elevations. Point numbers. I'm going to start with 101. It doesn't much matter. Just call this field and say, okay, we'll choose polylines. No radius points, no midpoints, no duplicates or draw. Okay. Draw the new points. I'm going to set that here, and boom, there it drew some points. Okay, representing these. Now, I don't even need, say, this line, the old original back. I'll keep it around, but I don't need it. I'm going to change its color so we can compare the two once we're done. All right, so now I've got points along my deed over here on the left, and I've got some points that I found out in the field over here on the right. And maybe there's a couple of other little points around here that I'm not sure if it's the right point or not. In fact, let's do draw locate points, and I'll just screen pick, and maybe I've got a point, another point over right here. That was, call it field as well. And that was another point. What was that? 107. So I've got 101, 2, 4, 6, and then 7. All right. So I've got some points. And I need to compare this set of points to this set of points to see how I'm going to resolve this deed, and if I can use these points out in the field. So I'm going to go to my point or my survey menu rather, and I'm going to choose deed tools. And then when I get that over to the right, I'm going to choose deed correlation. And when that comes up, I'm going to give this a correlation file. And again, go back to my data sets. I'll just call that deed. Core. Say open. And now what this is going to do, for those of you that don't know, Brian, I realize you do know. I'm going to go ahead and close off this. Let me bring this guy back up here in case we need it for anything. Okay, and now, so what this is going to do is it's going to let us create a list of paired points. You see the two columns in our box right here, survey point versus deed point. That means the field point versus the paper point, okay? And you choose down below how you want to make your alignment work. So I'm going to go from deed to survey. Then I'm going to take these points and I'm going to compare them over here to survey and see how those compare. That's just going to be my direction I'm going to use. Now you can add, see, I could have added that polyline directly, but I want to use these discrete points because I'm not going to necessarily know this yellow line at all at this stage. I've got some points out in the field. I want to see if they're going to match my deed. So I'm going to add some points. So I'm going to add a point, and I had a point number 1. So my survey point was 101, and my deed point was 1. All right, and I'm going to add, my deed point was 2, and I think that was 102. Let me screen pick. Yeah, there it is. Pick the deed points. And pick the survey point. What? Why won't you finish? All right, so there it is. Guess you have to press escape. I'll tell you that. All right, so if I screen pick, added a point. Sorry, add, add a point. So screen pick. All right, so now let's pick the survey point. So here's my survey point 103. Pick the deed point 3. Okay. So I just keep going now. So I'm going to say 107 compared to 4. 104 also compared to 4. And then 105 compared to 5. And then finally 106 compared to 6. And that should be all I need. I'll hit enter to end. And so now I've got these pairs matched up. The field points 101, 2, 3, 4, 5, 6, and 7. And so I've got 2 of these. As you can see, they're going both compare to that deed point. All right. I've got that. I can save that. Now, as you're doing this work, just like that deed file, it's going to save this list of correlated points that you can go back and edit later if you need to. So the different reports, here's my inverse reports, and they're just exactly what they are. They're inverse between all the points. So here's my survey point 102, my deed point 2. Starting at 102, it's going to compare all of the survey points. So to 101, to 103, to 107, same thing for the deeds, 1, 3, 4, 5, 6. So you can look at that, and in this case, because the rotation and the positions are out, the bearings aren't going to help us much here, but you can see it. All right, so right there's an exact distance match, 166.45. And that's also 165.45. So 165.45 here. So that's probably a good bet that those are the same things. But you can see here's one that's not quite exactly the same as this one. It's slightly off, and you can get an idea. This just information is all it is. Okay, just showing you there's a pure inverse from each point pair compares the inverse of its own category of points. So the survey points to all the other survey points. Go to the D point, all the other D points. All right. And then you can do a comparison before you do an alignment. And this compares survey to D points. So there's 2 and 2 and 1 and 1. So had I moved this stuff, moved these points real close by here, and I wasn't sure which they were, that's another way you can compare that little cluster. But again, I'm a long way away from those points, and it doesn't really matter, but you can see my deltas are in the 600. So it's not going to really give me much for that. All right, so then you can check an alignment, and that is going to be where you're going to hold a particular point. So let's hold point 1. That's my D points. Notice in the column there. So I'm going to hold and pivot about point 1, and I'm going to check it across the rotation. So 1, 2, I'm going to go to point 3 and see what that looks like. So if I hold point 1 and rotate everything into that point 3 direction, I'll say, okay, and this is okay. If you're holding point 1, which is equivalent to survey 101, your rotation point here, so that's going to be how much you'd have to translate and rotate to get around your average residual distances. So you can see how it would have to stack these up. So these are pretty good fits here, 2 and 3, 4 of 2.393. That one's probably not the right one at 107. But look how nice, how much nicer, at least 0.104 fits. Okay, so it gives you a little sense of maybe that would work, but that's only if you're holding 1 and holding the rotation into 3. What if we're holding 2 and rotating into 4? Well, we could check that as well. Check the alignment. We're going to go 2, and we're going to rotate into 4. Whoops, 4. And there's the same type of deal. And so now you can see you got some bigger numbers here. So there's probably not as good a fit as that's my deltas rather. Here's my 111. So still they're much larger than the last one. So, probably not the answer we're looking for. But in any case, that was the check alignment that lets us do some things we might be suspecting. But if we find the minimum alignment, I'm going to choose that button. That is going to find the mathematical least amount of manipulation that it needs to do to make these correlate, to make these match up. So it says, okay, you need to hold point 1, hold your D point 1, and rotate everything around in the direction of the 0.5. So that's 1 is up, where we started here, and then 2, 3, 4, 5. So we, along that line, is going to set that rotation. So that's D point 1, survey point 101, D5, 105. And then it's going to come up with this little residual of change. And you can see how much, these are very much smaller numbers. This one, however, that number 4 to 107, I can see that's a bit of an outlier. I can see that that's not going to be, in my interest to use. I could either go back and take it out. So that 107, maybe I could remove. And then I could find the minimum alignment again. So now as 1 looking at 3 gives me a better rotation. So I've taken that out. I've got my residuals are much smaller. I've still got a little bit, I've got about a half a foot of mist down there on point number 4. So that's all right. That's as good as we've got. All right. So that gave us whatever that alignment is going to find that minimum alignment. Now, the next step on this, and Brian, I'm not sure that you're doing this, you tell me or not, because you take it to a surveyor for her to look at. But let's say she goes, yeah, that's fine. Do you go back and then do this apply alignment?
I'll do the fine minimum alignment, take out the ones that I don't think agree. You know, I get my best average, and then I apply the alignment, and then I hand it off to her. And then she'll take a look at it, and she'll see like, okay, this is, you know, a bound that's tipped, or an iron rod that's a foot down. I don't know. It just all depends on what she makes that final decision. But I'm trying
Yes.
to give her a best alignment.
Yeah, certainly. And she could also, there's rules of evidentiary precedent as well, something has seniority, something else, that all kinds of stuff. So so this alignment, apply alignment. Now here's a little gotcha if you're not used to the apply alignment that always got me before that I wasn't I didn't realize was happening, that was going on. So I'm going to say apply alignment. So it's taking these ranges of points. There's 2 and 1, 3 through 6. And that's just reading out of that list. So really I could just say, I could result, so 2 to 1 and then 3, 4, 5, 6. I could really just say 1 to 6, but it took it out of the same order that my list was in. And here's my hold point, my 1. It's going to go to 101. Here's my rotation point. So 3 to 103. So that's going to govern the alignment. And then I want to write down here, this is the part that I was unsure of once upon a time. Align screen entities, ignore elevations is fine. And so when I do that, here's what's going to happen. I'm going to say, okay. Now it says select entities. What do you want to align? Okay. And so it says select the objects to align. And this is the important part. And I didn't realize this. It says points excluded. So if I were to draw a window around all of this, what's going to happen? The alignment is going to already move the points. And then it would take those moved points and move them again. Okay, so you get that double shift. That's why it says, points excluded. So the only thing I'm going to align is going to be that boundary. Enter, and off it goes, and it's going to put it what on earth? Oh, I see. It's applying. I've never seen it do this before. Align 6 points. So it left that 0.7 over there. I could just, that was my closing point. I could put that there, and wow, it even brought the annotation over with it. Because now, why did it do that? Does anybody know?
Because you did it in the deed. You
Well,
stored it as lot 137, all as one deed reference.
Well, no, not necessarily. When I moved that red boundary, that's just a polyline. But when it repositioned itself over here, why did it redraw these annotations? This has nothing to do with the deed part necessarily. I just wanted you to think about what
I believe it's automatically as you rotate all the all that stuff is being adjusted as from north point, as they keep rotating, everything keep adjusting automatically, I guess.
Yes. Well, yeah, you're thinking along the right answers. But here's the reason. In my settings, you Carlson configure under general settings, right over on the right. I've got turned on link labels with line work. So when I created that original deed and I told it to draw the labels, to when it was over here, I said, draw the labels. And so it did that. And it now, because that was linked, it's tied on. So if I take that line, that red line, and if I were to, move anything about it, see how the labels recompute and redisplay where they are? That's why they did it, was because of that linking. It really had nothing to do with the fact that I did it in the deed reader. But if and I could have left them behind and not brought them with it and then just re-annotated after I repositioned it. That would have been fine as well. But I want you to start thinking about, when something behaves a certain way, try to think your way through as to what causes that to happen. And that's because of that linking. And if I don't like that to happen, if I don't want it to happen, and the reason I bring this up is because when we're working with deeds, a lot of times we are going to annotate the actual deed description, meets and bounds. And it might not be, there might be a little tweak here and there, a thousandth or a second of arc or something that is not exactly the same. And so if you have your labels linked to your line work and your line work changes to where it's, been sort of hammered into this other mold, you don't want those deed calls. You don't want your meets and bounds to change necessarily. So, sometimes you want it on, sometimes you don't want it on. So just be aware of how that works and why. Okay. And you can see down here, we had this couple of these points that are slightly off. You can see the original yellow line versus that deed line. So right there's a miss on that point, but that's as good a fit as it can give us on this whole thing. See there, it misses a little bit there. Because remember, I scooched those out a little bit, but it still did a pretty good fit. And see, that's a little bit off. Yep, and well, mouse is going nuts here. Oh, it's because my hand's dragging across my trackpad. Okay, sorry. Yeah, so you can see that was, a way to really get that deed into position, find it on the ground, and it's a nice little tool. Now, the thing that I can then do from that, if I were to, or one thing that it doesn't do, rather, let me say, is it doesn't, if I go back to now my process, my deed file, excuse me, there's my 137. See, it did not go back and change any of this stuff, right? It's still that original deed that I typed in, but it brought all those points out there. Now I could have, let's see. If I do that, let me add. One seven revised. Oh, no, sorry, that's an actual point. Name any deed. No, that is lot 37 revised. Pick the point, it will be right there. Okay, I was looking for a way to be able to take it in graphically. Yeah, it's not. Let's see, what else might I have done it? Because it can let you can do that. You can create your correlation pairs of points let's say if I've got this here and I wanted to create some points under my deed correlation. I could say add this polyline. And now the deed polyline. So you see what it's done is it's actually created the points. Now I went through and manually created the points on mine, but now I've got points that are called S1, S2, S3, and I've got a D7. And all these other points were exactly on there anyway, so they came with their original work. But if I had done a separate, in fact, let's exit that and let's do this with a new one by polyline. So if I choose add polyline, it says select my survey polyline. So that might have been this one over here. And now
Hey,
select,
Ken.
Yeah.
Sorry to interrupt. I have a meeting scheduled for 5, so I gotta jump off.
so yeah, so there you go. So it just picks those up from the graphics. But it doesn't go back and hold that deed file. Okay. So, all right. So that should give us a taste of all that stuff, but take a look at these other exercises as you need, go through it, hit your help system. If you've got any questions, any issues, remember, right here, my email's there. Just always, stay in touch with things, and I'll wish you guys a great weekend.
Thanks, Ken. I appreciate it.
All right,
Okay,
guys.
perfect. Thank you.
Yeah, you guys take care.
All right.
You too.
Bye-bye.
Bye.
Bye, thank you.